Testing 1 2 3. Testing 1 2 3. I think we're ready to come back online if I'm not mistaken. Sorry about the wait, guys. It's kind of been a pain in the butt getting the stream set up here. It always is with the programming stream. Yo, what's up? Welcome back to Vencabot. Intro to Python action. My name is David. We're teaching Python here with the total beginner in mind. That is to say, people that have never programmed before in their lives want to start picking it up a little bit. I think Python's a good language to be your first language, and it's my favorite language. So that's kind of what we're kind of focusing on today. We're listening to the music of my friend Aubdat. That's Aubdat, aubdat.bandcamp.com. That's aubdat.bandcamp.com. Very, very cool guy. His music is sort of like ambient, kind of droning, sort of swelling or resonant, very dark, kind of cold. And I find it's very good for programming and studying and that kind of thing. His music is all available for free on his Bandcamp page. Some pretty cool stuff there. Go check that out. He's also, twitter.com/TC640B. He's at TC640B on Twitter. Oh, maybe not. Maybe he removed his Twitter. I don't know exactly. What's up, Zanzu? Welcome aboard, dude. I also have the Python standard library open here. That's docs.python.org. That's docs, docs.python.org. You go to the library reference. This is pretty useful if you want to learn like Python libraries. This is more of an advanced thing though, but for me it's good for like a reference. For you guys, don't worry about that quite yet. So let's look at where we were at last time when we stopped programming, huh? That would be our adventure day 1. Now I'm going to save it as day 2 now. So what do we have here? Well, we've got some function definitions. Okay, that's cool. Actually, I should probably scroll the scroll bar so it doesn't judder. Okay, we got some function definitions. Okay, we got some flags, looks like, some booleans as we call them, right? Booleans are like true or false values. Here we have like a variable name, chest is open. Right? We know it's a variable name because it's on the left side of an equal sign. That means this is the assignment operator. So a variable, as you guys already know, of course, is just a name for a piece of data. So the data we're naming here is false. Right? We're making this little false statement here. This is false. Whatever it is, whatever this is used for in the future, it's not true. Right? It's false. And we're assigning this value the name chest is open. So we know that chest is open is false. We know that player has key starts off as being false, and adventure is ongoing starts off as being true. So it's a bunch of Boolean values, right? We talked before about the types of data you can use in Python. We didn't cover all of them, of course. There's countless types of data to use, but the most basic things are like, integers, which are like, simple numbers. We talked about floats, which are, floating point numbers, aka like decimal numbers, things that are like fractional. We've got strings, which are textual data, like you are in a cave. This is a string here. You can tell because it's got the quotation marks on either side. That means it's a string. Oh, I just realized we were in Notepad before. Should we open Notepad, guys? Why don't we? Yeah, let's make it more like last time, guys. Let's not get into this. This is a program called Idle here that comes with Python. This is a little bit more advanced. Let's not worry about that too much right now. Let's just go back to Notepad. I'm a silly goose. Let's actually open this up here and go to Learning Python. Go to our Adventure Day 2, right-click that, and open it with Notepad. There we go. Yeah, of course, Idle's a lot prettier, but I really want to, before we get into Idle the next time, guys, that'll be next Friday. Before we get into Idle, I really want to stress that it's a myth that you need to have cool software to write programs. You can just write using Notepad. We're going to go here to our Start button, click on that, and type in CMD. Get this command prompt application, right? Let's launch this. Boom. I'm actually going to shrink this a little bit. Shrinkity, shrinkity, shrinkity. Move it right around here so it's easier for you guys to see. Slide it down right around to this spot. Stretch it out that way to make it about the same width as Notepad is. And then shrink it a little bit. Yay! Okay, we're going to use the command. Remember we saved our, let's hit the command here in the command prompt. dir, hit enter. We can see all of our folders here, right? So I've got contacts, a desktop, documents, downloads, favorites, that sort of thing. But we also have our own folder we made, right? That would be called Learning Python right here. So if you use the cd command now, that's cd, means change your current directory or change directory. Change directory to Learning Python. So now we're in our Learning Python folder. If you hit dir again, dir, it shows all the files that are in that folder you're in. You see all of your Python files. For me, that's a few more than you probably have, because this is all the examples we've done in the past, on the past streams. Really, we're interested in Adventure Day 2, right up here. Adventure Day 2 is .py. So we're in the right folder now, we can run Python. Let's do py, that's how you run Python, right? Space, then the file name. That would be Adventure Day 2.py. Okay, so we're in a cave, what you want to do. So let's look at this. Do I have Idle open still? No, we don't. We actually closed that. Good. So we have Notepad open here, guys. I'm sorry. I forgot we were using Notepad still. So we have, again, our functions on top. And then we've got some assignments here. the Boolean assignments we've made. And then we print off some data. Print is one of the only functions we've used so far that's built into Python. We finally did define our own functions up here. But we're using two functions that are built into Python. One is print, which you supplied a string as an argument, or anything you want to print off. It could be an integer, it could be whatever you want, actually. You supplied some kind of data to print off onto the screen, and then it shows it on your screen. That's really all print does. And just like any function, when you call it, you give its name, which is print, and then you put its arguments, or the data that it needs to work, between the parentheses here. All right, so you have print, you are in a cave. All that does is it prints off some data. Let's actually go see that right here. That's right here, see? We ran the program, first thing it did that we saw was you are in a cave. And what's interesting is that although the first thing we saw was you are in a cave, a lot of things are going on behind the scenes that we didn't see. Programs are read from top to bottom, right? They're read from top to bottom. So the first things that this program does when you run it is it defines these functions. They all get defined. But as you guys know, although instructions in Python and any programming language are executed from top to bottom, so the Python interpreter begins reading instructions that you've written from the top to the bottom. But what it doesn't do, it doesn't execute any code that's indented. If that code is indented, like this here, see how it says print, it got these little blank spaces, 1, 2, 3, 4 blank spaces. That means that this code is only run under a certain circumstance. And any code that's indented is not necessarily run top to bottom. It's going to be run only in a certain circumstance. So for function definitions, that means that this code is only run when this function is called. Right, so we defined a function called lookaround, and later we can call lookaround. When we call it, it'll run this function, it'll run this instruction here. Likewise, when we call open the chest, right, we define this function here. You can tell it's a function definition because it starts with def, right, and then space. We have a function name. We have a list of arguments. This one has 2 arguments. Chest is open and player has key. This one has no arguments, right? Just nothing between the parentheses there. Welcome back, Zanzu. Welcome back. Any code block, that is to say any indented code, begins with a line that's not indented, like this function definition here. And then that line ends with a colon. Right, so if a line starts, if a line ends with a colon, that means you're making a new code block. So the rest of the code after that's going to be indented. So all this code here is inside of this function. Right? We call that being nested, because you can see that it's sort of indented here. It's sort of inside. You can think of that as being inside this block. And you can tell when the block ends because the lines stop being indented. So here we have all this code in this function. We actually don't want to drag that. All this code is inside this function right here, this open the chest function. But this is not inside of it, because down here you see that the indenting stops. Right? So this is the entire code block right here. And then here we have a new function block. Right? This all belongs to get the key, and this all belongs to leave the cave. See what I mean? It doesn't matter if it didn't say BRB sounds. All that matters is you're back. If you're here, I'm happy. It doesn't matter where you've been. It just matters that you're here. But where have you been, Zanzu? How's your day been so far, dude? Okay, so as you can see, some of this nested code is actually indented even further. It's actually indented even deeper, right? Like this here and this here. Look at all this indenting here. What that means is that you can nest blocks of code inside of each other, right? So right here we have a code block. This all belongs to open the chest, this function, right? However, here's another code block inside of that code block, right here. This belongs to this if statement. Right? We talked about before about how any line that ends with a colon, like an if statement, or an elif statement, or an else statement, see those colons there? That means that the following line is going to be indented and it belongs to a code block. That code will only run under certain circumstances. So in this case, if you call the open the chest function, right, if you call this function, then this code will run. But most of it's indented, right? So this code won't all run. In this case, we have an if statement that starts off as if not chest is open. So the argument we supplied here, the data we supplied into this little slot, we gave this function some data, and whatever that first piece of data is, chest is open, if it's not true, then do this. Right, so we're saying, hey, if the, so we say if not chest is open, we're saying if chest is closed, right? Same thing. If not chest is open, so if chest is closed, then print off, you open the chest, there's a key inside, and then you change a flag, chest is open is true. Right, so we're saying, if we want to open the chest, first thing we do is check if the chest is open. If it's not already open, well, you go and open it. And there's a key inside. Right? And then we can say the chest is now open. And And we say elif, so otherwise, if the chest is open, right? So if not chest is open, if chest is closed, do this. If the chest isn't closed, then check if the player has a key. So elif, not player has key. So if the chest is already open and the player doesn't have the key, then print off, the chest is already open, there's a key inside. And then finally say else. So else means if none of this shit is true. So it means that if the chest is open and the player has the key, then print off, the chest is already open, it's empty. Then we return this chest is open flag. So if it was one of these two options we took, then we give back the data that we got right here. However, if this data is run right here, if this code block runs, then chest is open gets changed, right? So if one of these runs, then just return whatever we had for chest is open. And if this one runs, then flip it to true. What command do you say to open the chest? In our case, go down here, we look at our commands. The command is open the chest. What we have here, guys, is a very simple adventure game. It's sort of like a Zork or a classic text-based adventure game. We have this little cave, right? You are in a cave, what you want to do? Well, I want to... Oh, look, we have some text bleeding over here. That's kind of a drag. I'm not going to fix that. It's a little bit deep. I can fix that real quick, guys. 1 second. Let's see here. Exactly. You can't spell it wrong, and you can't say open chest. Indeed, you cannot. Okay, guys, I'm going to... something terribly wrong here, didn't we? Let's actually go out of studio mode. Okay, so... let me move some text around here before we go too far. Some of this text is a little bit too far to the right. So why don't we go down here to the bottom. This is my little notes on the side I have on the left side. Okay, let's see. I want to reduce this by like 4 spaces approximately. Let's see here. 1, 2, 3, 4. 1, 2, 3, 4. I can live with that. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Shimmy it over a little bit closer to me. 1, 2, 3, 4. And then we're going to shimmy this a little bit too. 1, 2, 3, 4. Okay. Up here. 1, 2, 3, 4. Get a little closer to my noodle here. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. There we go. Okay, so let's see here. And we also have a little bit more up in the middle here. But being in the middle is not that bad if it's a little bit too long. That's fine. We can live with that for now. It's kind of a drag, but that's fine. Okay, so let's close this. I'm going to move my mouse and keyboard back over to the other screen, if you guys don't mind. I'm sorry, guys. For you guys that have not watched the first episode, I neglected to mention this is a little adventure game. So we have this little command prompt. It says, you are in a cave, what you want to do. Right now, we have only a few commands. We have no way of telling what the commands are yet, because we're kind of like making a little simple example game here. We have to use our code to see what we can do. We can look around, we can do a dance, we can open the chest, get the key, and leave the cave. So not very many commands we can do here. And like Zanzu said, we can't enter in the commands incorrectly. If we do, it says you can't do that. And likewise, we have to do them in a certain order. Let's see, for instance, if I try and get the key right now, it says you don't see a key. I don't see a key around here, right? Well, then let's look around. What can we see? If we look around, it says the cave is dank and there's a treasure chest. Okay. So now can we get the key? Okay, we still don't see a key. Let's do a dance. Okay, so I did a dance. As you perform a breakdance maneuver, what style? Let's open the chest. Okay, so you open the chest, there's a key inside. Let's leave the cave. It says, aren't you forgetting something? We can't leave the cave here. It says, aren't you forgetting something? We can't leave the cave here until we get the key. So we open the chest, there's a key inside. Why don't we open the chest again? All it does is it kind of gives me a message that says, the chest is already open. There's a key inside. Well, then let's get the key. Okay, now we got the key. We couldn't see the key before, now we got the key. We can see it now. And now we can open the chest one more time, so it'll give me a message saying, it's already open, it's empty. We already got the key. Now we can leave the cave. And that ends our program. So as you walk out of the cave, game over. Very simple little game there. All you do is find a chest, open it, get the key, leave the cave. But it's interactive. It's kind of cool, right? Okay, so now we know how the game works. Let's look at how it works. Right? It's actually not that complicated. Really how it works is that it just uses this input function, right? So we talked before about how we're only using 2 built-in functions in Python. We defined our own functions up here, but the 2 built-ins we're using are print to show the player some messages, and input for getting the user's input, right? Getting their command, basically, right? What they want to do from what they want to do in the game. So what we're doing here is we define some functions that are like, how the game operates, right? Like look around, do a dance, open the chest, get the key, leave the cave. Some little simple functions there. Then we define some flags, like the state of the game. So the functions know how to operate. For instance, chest is open starts off as being false. That way we know at the start of the game the chest is closed, and later we can open the chest and make that flag true. But once the chest is open, that becomes true. Likewise, player has key. The game starts off, player does not have the key. Right? But we can get the key later, so that flag gets switched from false to true at some point. When we grab the key, player has key becomes true. And adventure is ongoing is true. This is used as a way to know when to stop asking the player for input. Right? So as long as the adventure is ongoing, we keep on asking them over and over again, what do you want to do? What do you want to do? What do you want to do? And then when they get the key and leave the cave, the adventure is ongoing, becomes false, and then the game ends. So the first thing that happens here is we print off a message, right? It says you are in a cave. And then we start this loop. So while adventure is ongoing, run this code. We talked before about code blocks, right? Code blocks only run under certain conditions. In this case, the condition is the adventure has to be ongoing. Right? And while blocks are different from if blocks, right? Because if blocks, like, as you see here, right? If player has key, then do this. Otherwise, do this. Right? While is kind of similar because while this code will only run if this statement is true. Right? So it's kind of similar. If adventure is ongoing, while, let's just try if, right? Let's just replace while with if. There you go. So if adventure is ongoing, then do this. All right, so let's run this code again. Go back to our command prompt, hit up to get the last command we ran, hit enter again. So you're in a cave, what you want to do? I want to look around. Okay, so it says the cave is dank and there's a treasure chest. Game over. All right, that didn't work, right? So I looked around and it gave me the message in response that I wanted. The cave is dank and there's a treasure chest. Then the game ended. That's because when you run an if statement, it only runs once. Time to move on. Exactly. We fucked up our game. Let's move on. Yeah, so basically we say, if adventure is ongoing, and that is true, right? Right here it says that. Adventure is ongoing is true. So, if adventure is ongoing, then run this code. And then game over. So there you go. So exactly what happened, right? We, asked the player what they wanted to do. Right there. And then we tested what they ran. Right? Let's say, if player command is look around, then run this function. If player command is do a dance, then run this function. If player command is open the chest, then run this function, but also get back the chest is open value. All right, so I'm going to talk about that in a minute here. And finally, get the key, leave the cave, it's kind of similar. And then else, so if the command is none of the above, then print off you can't do that. And then print a blank line, and then, the block ends. But if we use while instead of if, now while has a different meaning, right? While says, keep doing this block over and over and over again as long as this statement is true at the start. So we read this, it says if, adventure is ongoing, then do all this code. Then it asks again, is adventure ongoing? If it's so, run all this code. Then it asks again, is it ongoing? Then keep on doing it until this is false. Once this becomes false, then this code stops running finally. Right? So once we get down to the bottom and ask again here at the top, is it ongoing? Well, it's false. Then we jump down here to the bottom. Print game over. Right? This code doesn't run anymore. So that's kind of why we need the while loop there, to keep the prompt being asked to the user right here. We want all this shit to happen over and over and over again. While is great for that. That's what while does. It does the same thing over and over and over again. Kind of cool little block there. So let's talk very briefly about these functions we've written up here. Right? As you can see, what we're doing here is we get the input from the user, and we save their input as player command. We can name that whatever we want to. We call it player command. It's just a variable name. We can name variables whatever we please. We're calling it player command. Then we're saying, hey, listen, we're comparing this player command to some strings. Right? So we're saying, hey, listen, if the player command is equal, that's a comparison operator. That means it compares this to this and returns true if they are equivalent. Otherwise, it returns false if they're not equivalent. So we're saying, hey, listen, if player command is equivalent to look around, then run our function, look around. Elif means, if this wasn't true, then ask another question. That's what elif means. If the previous was not true, ask another question. So if it wasn't look around, then is player command equivalent to do a dance? If that ends up being true, then do a dance. Previous things get a little more complicated, right? We say elif, so if the previous two statements were not true, if the player command is open the chest, well, we're not just running a function like here and here. We've got a little more of a complex line here. What's all this about? Well, that's because open the chest, for one thing, it takes arguments. And arguments are data that you feed into the function. So both look around and do a dance did not need any data to do their job correctly, as you can see up here. Their job is very simple. They just print off a single line of text. They don't need any data to do their job correctly. Right? Look around just prints off that data. Do a dance just prints off this shit. However, open the chest requires two pieces of data, and they're separated by commas. That's how you do arguments in a function. You supply them between the parentheses. So as you can see here, these parentheses have nothing between them, no arguments. However, this one has some stuff between its parentheses. And that's two pieces of data separated by a comma. You separate arguments by a comma. So we have chest is open, and we have player has key. And we define those two up here, right? So we're supplying this thing with two arguments, false and false, at least to start off with. Right, so we're supplying it with false and false. And let's go up and see how this data is used by open the chest. Okay, so it takes these two arguments, right? And first thing it does is it does, so we actually went through this very briefly last time, but or a few minutes ago. But it compares chest is open first. Right? It says, hey, listen, if the chest is closed, so if not chest is open, not is a simple statement that reverses a boolean. Right? So not true is equivalent to false. And not false becomes true. So the word not just reverses whatever follows it. Don says the key is key to this story. Yes, we're going to actually make that even more interesting today. We're going to actually use the key today as we get going. I'm still kind of reviewing, though, from last time. But yes, the key is going to actually come into play here, finally, starting today. So first thing it does is say, hey, listen, if not chest is open, then do some shit. Likewise, we have to use this player has key argument as well. So we say, if not player has key, then do this, right? But here's what else happens. So we used our two arguments, right? We actually make use of our arguments to do our job in this function. But then we return a value. Return chest is open. Now here we have no return. There's no return statement there. Here we have no return statement. But here we have a return statement. Now, what return does is it ends the function, for one thing. Even if we put it at the very top, like right up here, like, let's just say, return chest is open. It ends the function right there. So none of this code would ever run down here. That would never, ever run, because this would just end the function right here. So it ends the function, first of all, but also it gives you back some data. So chest is open takes two arguments, and then it returns some data. And when you return data, you can assign that data to a variable name. That's why this line down here looks so long. Right? Do a dance, very short line. But here we have chest is open equals open the chest is open, player has key. So what we're doing here, let's break this down real quick. First of all, we're calling this function open the chest. And we're supplying the two arguments that it wants. Two Boolean values, that is to say true or false values. And then this returns some data, right? It returns open the chest is open, so it returns whether or not the chest is still closed or open. And then we're saving that to chest is open. So whatever this returns back, be it true or false, that becomes the new value for chest is open. Right, that's what we're assigning here. So just like up here, as you can see, we're assigning player command equals, then we're running a function, input, what you want to do. So what you want to do is the argument for input. That's the prompt you get, as you can see over here. That's our prompt right here, what you want to do. But also input returns some data. It returns whatever the user typed in, and we're saving that to player command. So whenever you use the assignment operator, right here, the equal sign, usually, I shouldn't say usually, but oftentimes you'll just give it a raw value, which is called a literal, right? Like false, or true, or the number 1, or a string. Right? You're giving it a literal, that is to say, you're giving it some piece of data that's very easy to understand visually. It's just, it's false, or it's true, or it's a word, or it's a number. However, you can also assign the value returned by a function. So when you have a function like this, we evaluate that function, as we say. That means that we get data out of it. We get the return value out of it. Then we can save that data into player command. So although we see, as programmers, we see the function name, right? We see this function call right here. But what Python sees is not the call itself. It sees the data that it gets back from that function. So player command is not equal to a function. Player command is equal to whatever data comes out of that function, right? Which is to say, whatever the user types in. And that's true of this statement here as well. It says chest is open equals open the chest. It's not equal to a function. It's equal to the data that's returned by that function, which is to say a boolean. We found out open the chest, right, returns a boolean right up here. Right? It returns chest is open. So it'll return whatever was fed into it, right? Unless it was changed right here. Then it feeds it this. Kind of cool. Likewise, we have a similar thing going on here with get the key. Right? If the user tries to get the key, as you see right here, if the player command is equivalent to get the key, then we assign a new value to player has key. Right? Because if you're trying to get the key, then that means that there's a possibility, a good possibility even, that your flag player has key is going to change. Right? Let's say you don't have a key, or you start the game with no key. Right? Player has key is false. But if you try and get the key, then it might become true that you have the key. That's why we actually have to use this assignment here. Because the only way to get data into that's not fair to say. The main way to get data into a function is to give it arguments. Right? As you see here, these arguments, they go into the function. Now the function can use that data. And the main way to get data out of the function is to return. Right? So we can't just change player has key inside the function itself. Right? We have to assign a player has key outside of the function. So get the key runs this code, right, for getting the key. But all things that happen inside of a function, it's like it's like a Las Vegas, right? I almost said New Vegas. It's like Las Vegas. What happens in a function stays in a function. Right? What happens in a function stays in a function. So once this function is over with, all of our variables we made in here and anything else we did inside this function, it's gone. It's gone forever. So you can't just assign data to a variable inside of a function and then use that variable outside of that function, because what happens in a function stays in a function. Right? Like Las Vegas. What's Starkey? For that reason, when you want to get data out of when you want a function to change something in your game or in your code or whatever, usually you will return data out of it. Right? You'll say, I took in this data through my arguments, I did some shit to this data, now I'm giving you back some data. Right? And that's how you get data out of there, using the return function. That's usually how you would do it. Because everything else in here is just gonzo. So if I did this, let's just say that I, get rid of this line right here. So for now we have get the key, and it has no return value at all. We say, if the chest is open and not player has key, you picked up the key. Right? So you get the key right here. Player has key equals true. However, player has key equals true. This is not the same player has key as this is, because they are at different scopes. Right? Scopes. Let's talk about scope. In programming, there are certain situations where you can have two pieces of data by the same name, but they will not be the same piece of data because they are at two levels of importance to your program. Right? So up here we define player has key equals false. This is, as you see, all the way flush against the left side of the screen, so to speak, the left side of the document. That means that this is at the highest level of our program. It's not in a block at all. We talked about blocks earlier, right? It's not in a block at all. So this is like a really high level variable. Player has key equals false. However, this is indented into a block. Right? In fact, it's a function definition block. And function definitions have a different scope than the ones in your, all the way flush against the left side of the screen. Which is to say that you can name things here whatever you want. We can name a variable player has key, but that doesn't actually change this value. Right? It doesn't actually change that value outside. It's only for this side. It's only inside this function that it works. So although we can actually change the value inside here, it doesn't actually affect the rest of our game. The only way we can make it affect the rest of our game is by returning the data out. Thanks for the follow, Lex Abre. Welcome on board, dude. We do programming here on Fridays. It's a 40-hour-a-week gameplay stream. We do a lot of video games here. Don't get discouraged if you see me playing Street Fighter or something like that. We actually do programming here every Friday. We do a lot of stuff on this channel, but programming is here weekly. Let's return player has key. Cool beanzos. So yeah, the data you mess with inside of a function definition, that does not affect the rest of your program. It just doesn't. Look at it that way. Hey, what's up, KG? Programming every week, dude, and soon to be even more. Soon to be even more, but not quite yet. So yeah, so anything you do inside a function stays in that function, unless you return the data out. That's what we're doing here, right? We're giving this key back to the rest of the program. So we changed whether or not you have a key, and then we feed that data back out, so you can actually use that data somewhere else using the return function. So here you can see we have, player has key equals the result of get the key. We supply some arguments here. Chest is open, player has key. A little bit complicated, guys. Kind of moving along pretty quickly here. But if you guys have any questions, let me know. Especially about the very basics. We could always do a very quick review of the very basics of functions, for instance, right? The very basics of functions. What is a function? How do you call a function? What the hell is an argument? That kind of thing. All right, we have finally one more function here, which is one more command, which is leave the cave. And once again, that changes a value, right? Adventure is ongoing. Because if you leave the cave successfully, then this flag, adventure is ongoing, must be turned to false, right? That's why we return some data out of that too. So we supply, the only data that it needs is, do you have the key? Right? We give this function, does the player have the key? And if you don't have it, then we return, true. Adventure is still ongoing, right? If you do have the key, then we return false. Adventure is not ongoing anymore. And then you can actually finally get out of this loop, right? While adventure is ongoing, so while true, keep doing this. Once that becomes false, then we can finally end this loop and get down here to the game over part. And that's it. As it says right down here, when Python on dot of instructions is read, the program ends. As you can see over here on our last example, the program just ended finally. If I actually run the program right now, what you want to do, I want to, do a dance, right? Then it asks again what you want to do. So it's just looping, right? It's looping over this, these commands here, because adventure is ongoing is still true. And as long as this is true, this loop will keep on happening, where it asks what you want to do and then acts on your command. So it just happen over and over and over again until we finally break out. So let's we have to look around, right? So we see the chest. We have to open the chest. Okay, get the key. Okay, and now we can leave. Right, it says game over. Then the program ends. We get knocked back to the command prompt. The Windows command prompt right here. So that means the program's over with. That's because it ran out of stuff to do. Once it runs out of stuff to do, the program ends finally. That's kind of cool. Also, you can actually force kill a program in the command prompt, the Windows command prompt, by using Control and pause. Right, so hit up, hit enter. So we're running the program. We can do a dance or whatever. Right, we can do whatever the hell we want. If we want to end it before getting the key, let's say I want to fucking kill my program for whatever reason, you hit Control and pause on the keyboard. Boom. That'll actually kill your program forcefully. Now you're free to type in another command here. So Matt's learning Python too. Nice, Matt. Welcome aboard, homeboy. Where are you at in your studies, Matt? Want to talk about something in particular? Probably a little bit further in than us. We're still very much beginners here. We are still very, very much beginners here. Learning the very, very basics of programming in general. Okay, so we've discussed how our program works so far. I kind of did a little review there real quick on how our program is working. Why don't we begin improving our program a bit today by looking at some new data types? So before let's actually do a very quick example here. I'm going to actually make a new document. We're going to save this as simple data types .py. Right. So we talked about some data types, right? We talked about numbers, right? Like an integer, like 1, right? So I'm actually going to put some comments here for you guys. We talked before about how when you start a line with a pound or a number sign or a hashtag, as they say, that means that Python will ignore that line. So we can use that for commenting our code. We're going to say, ints are simple whole numbers, right? So this is an int right here. We can say, floats are decimal pointed fractional numbers. We talked about these kind of numbers too, right? We can say another number is 1.5. That's a float. Right. So Matt says, I'm past the text-based games and I'm learning web development with Flask. Oh, nice. Databases are very interesting to mess with. They are indeed. What are you using? The built-in databasing software in Python? What does Python use? I forget what Python uses exactly for databasing. A little bit complicated indeed. Databases. They're kind of hard to understand a little bit. I hope that you've probably already been through like dictionaries and that kind of stuff first. Sounds like you're quite a bit more advanced than we are here. We also talked about strings, right? Strings, which are also called str, represent text. Usually to be shown to the user. Right, you have this text as well. But the Windows UI is killing me, says Tefram. I don't like Notepad, huh? Yeah, we're still, I'm really trying to use Notepad today to point out to new programmers that you don't really need software to write programs. You can just actually use Notepad wherever it comes with your operating system. It's simpler than people realize, but indeed it's a little bit ugly, very, very bright white. Matthew says, get Sublime Text. It looks better than Notepad, indeed. Yeah, I'm using Idle a little bit too. In our future lessons, we use Idle here in this channel. But yeah, we use Notepad here for the first couple lessons. Yeah, so Vim, I use Vim when I program stuff for Tefram for my own pleasure. But here on stream, we use either Notepad to start off with and then Idle. Because again, every newbie programmer has those two things. Right? They have Notepad and they have Idle. Idle comes with Python. Okay, so strings, we can say like, some text equals, hello world. Right? So we have this little string there. And strings start and end with quotation marks. And those are all the, we can talk about booleans too, right? Booleans, bool, are either true or false. Right? So we can say, knows Python, that's true. Right? Now we know Python. So that's a true, you capitalize the T or the F in true or false. That makes it a boolean. Now if we did this wouldn't be a boolean anymore. It would be a string that says the word true. Right? That says the word true. It's a string, but it is not actually true as far as Python is concerned. But if we take away these quotation marks, now we have this value of true. This value is used for things like if statements and that sort of thing. Comparisons. KG says, I tried Python back in the day. Someone hooked me up with an Eclipse and PyDef add-on. Yeah, I hope you enjoyed it, KG, but I feel like when you take a total novice programmer who's never programmed before in their life, and you give them an IDE, some kind of development environment, it can be pretty intimidating. It can be pretty scary at first. So that's why I really want to stress using Notepad at first, to say, listen, just use Notepad. It's all you really need to program with. And then as you become, as your needs sort of grow as a programmer, we can look at other software to use. Again, like Idle, which comes with Python, which makes it look a little bit nicer. It highlights certain things for you, make it a bit easier to read. But at first, all you need is this black and white Notepad type stuff. Matt says, I'm using VS Code with Python add-on. Okay, we're talking about different IDEs they're called. I think it's Integrated Development Environment, I think what that stands for. Which means, if you guys are total novice programmers, you might not realize, but there is actually software out there that will make your code easier to read and to write. And it makes it easier to read by highlighting certain things. So it'll actually highlight numbers and strings and function calls, so it's easier to skim through very quickly. And also will sometimes autofill things for you, like it'll actually autofill some arguments for you. You don't have to type everything. It'll auto-indent sometimes. It saves you some typing. But as a programmer, it's kind of important to understand how to write programs in plain text. What's up, Kinmag? Welcome aboard, dude. Tefram says, Kate does that. Who's Kate? So I think these are the types of data we've talked about before, right, in our stream. We've talked about integers, which are whole numbers, floats, which are floating point numbers, or decimal points in there. They're like fractional numbers. Strings, which are text, also referred to as str in Python a lot. Str is a string. That's some text for you to read. And we talked about booleans, or bools, which are true or false values. But today we're going to actually utilize some more data types. For instance, we're going to talk about tuples, right? And tuples are grouped data that's processed at the same time, right? So it's basically when you have data that is like two or more pieces of data that are so closely related that they're not meant to be separated, right? So we can say like, for instance, we can say like a coordinate is, 10, 7. That's an x and a y value, right? Let's say you're making a graph, right? So you have this x and y coordinate here, and they're processed together. And tuples are surrounded by parentheses. And you can kind of group data together that way, right? For instance, we could also say like, my name, right, is, David Hernandez, right? So that's a first name and a last name, right? They are separate pieces of data for our example here, but they are very closely related pieces of data. You're going to need to know my full name, right? You could even put a middle name in there, right? You can put in whatever the hell you want. But it's like you have this tuple, which is itself a piece of data. The tuple is itself a piece of data, but it is made up of two or more closely related pieces of data. Let's see here. So Kate is one of the editors in the KDE suite. Okay. Right. So Matthew says the most intimidating part of learning is if you use an online course that holds your hand through the process. And once you're on your own, you might be stuck. Indeed, I totally understand that. Kimax says, by the way, do you have any ideas for a good beginner project apart from a calculator or a guessing game? Hell yeah, Kimax. Yeah, we actually did Pokemon. If you go to our YouTube channel at youtube.com/Vencabot archive, or just search on YouTube for Vencabot, you'll find our previous episodes of Intro to Python. Our season 1 started off with the total basics, right? The total basics of like what is a variable, and then it ended in 6 episodes with us having a fully working version of a Pokemon battle. We could actually make our own Pokemon, make our own moves. It was pretty cool. And right now we're working on a Zork-style text-based adventure game. So you kind of like walk around, pick up objects. It's kind of like a game. It's kind of cool. Matt says rock, paper, scissors. Also a good idea for a beginner project. Yeah, tuples can have as many as you want. We could have, like, let's say, for instance, let's do one more tuple. Let's do something like, what's a good example of some closely related data that's all processed at the same exact time? That's all, it's kind of all... So tuples aren't really used that much anymore in Python. They're really used more in other languages, but it's important for that reason to understand how they work. If you ever want to move to JavaScript or you want to move to another language like C++ or whatever, tuples are kind of like a commonality in all languages. But you could put in like a middle name there if you wanted to. You could put in like, Steve Burt if that's your middle name or whatever. Or, it's just basically any kind of data that's related. It can be fucking, 10 long for all I care. Right? It could be like, you have a huge name. You could have a huge coordinate that has a z value, like XYZ, for like if you want like a 3-dimensional coordinate. Basically, it's any amount of closely related data. Oh, thank you, Zanzu, for that hook up there. We just finished Intro to Python Season 1 here, where we started off here in Notepad and ended with something a little bit more advanced after 6 episodes. It was kind of cool. And now we're in Season 2, guys. We're really back to basics here for a whole new season. Nobody knows anything about Python anymore. We're kind of returning to the very basic ideas here. Okay, so also I want to talk about a kind of similar idea that's used a lot more often in Python, right? The idea is of something that's iterable. Now, an iterable piece of data, we talked here about how a tuple is itself one piece of data. Right? The tuple is a piece of data, but it contains 3 or 2 or more very closely related pieces of data that are processed together. Right? They represent one idea. So basically, a tuple is like multiple kinds of data or multiple pieces of data that represent one idea. Right? Now, an iterable is different. It is also a collection of data. Right? It is one piece of data, but inside of it is, more than one piece of data. However, an iterable, the data is not all directly related to each other. It is really more like multiple versions of a similar idea. And the whole point of them is to go through them one by one and process them in some way. So let's just say here, we're going to say, iterable, or a list. They're commonly lists. Is, a bunch of similar data to be processed individually. If you look over there on my, above my head, you'll see a bunch of notes for you guys, and I kind of mentioned that on there already. But an example would be like, let's say like colors. Right? Colors, we can say, and lists start off with a square brackets, not round parentheses, but square brackets. We can say colors like, yellow, red, blue, orange, round, whatever, right? It goes on and on and on. And it ends with a square bracket. Now, these, unlike, David Steve Burt Hernandez, which is, one name, this represents one name, right? And 10-7, which represents one coordinate, one XY coordinate, these do not represent any one thing together. However, it's a list of things, right? It's a list of things. And you can process these individually using a for statement. We're going to talk about that later, right? We're going to talk about for statements later. we're going to talk about for statements later. But for statements go through every item in a list and process them, which is pretty useful sometimes. And finally, we're going to talk today about dictionaries. So we're calling them maps, right? Maps are commonly referred to as dicts, or a dictionary, is a way to associate, I can't spell today, associate data together. I'm going to show you an example of that real quick. So we can say, like, we'll say, I think I've used an example above, but it's like favorite colors, right? So we have a list of colors here, right? We have a list of colors here. But if we're going to associate some data, like let's say favorite colors, we'll say, we use curly brackets for dictionaries. It's a curly bracket. We'll say David, he likes, red. We'll say Steve, he likes blue. We'll say Zanzu, he likes green. So the way that a map works is that you can feed in one piece of data and get out the other piece of data. So here we say, if I feed in David to favorite colors, I get back red. If I feed in Steve, I get back blue. If I feed in Zanzu, I get back green. So basically we have 3 new kinds of data today, and they're all related to the idea of grouping data into a single piece of data. As we group a tuple, we group data into a tuple if it's all together one idea. And we group it into a list if we're going to actually have to go through every item in a list and do something to it. Right? Here's a list of some colors, for instance. And then we have a map or a dictionary or a dict. If you want to sort of get some data out by feeding another piece of data in. So here, if we want someone's favorite color, we can give it their name and get back their favorite color. What's up, Steve? How you doing, dude? So Facebook has no idea what's going on, huh? Yeah, something you missed our previous episodes here. Basically, we're talking about how every program, whether using Python or any other programming language, is made up of 2 kinds of things. It's made up of data, which is information, and operations, which are things you do to that data. And you can read the data and change the data and mess with things, right? So in a video game, we talked before about how the information might be your character's level, right? Or what kind of gun you're using, or how much ammo is in that gun, right? So we have information, where on the map your character is. That's all information, right? But the operations would be like shooting the gun, which would reduce the ammo. We have things like moving the character, which changes their position. You know what I'm talking about? We have things like killing a monster, which would potentially raise your level. So you have the data that you need for the game, and then you have the operations which make the game work. In this case, we're talking only about the data. We talked before about these very simple data types like numbers, text, true or false statements, and now we're looking at some more complex kinds of data which are made up by combining data. Right? So you have this tuple, like I said before, that's data that's very closely related. It's all processed at once. It's thought of as one thing. And a list, which is like a list of things. Right? They're not necessarily all related to each other, but they all have this similar idea behind them. They're all colors in this case. Then you have a dictionary or a map, which is when you take one kind of data and then you associate it with another kind of data. So we have the name David, and it's associated with this color because that's his favorite color. Happy to have you, dude. Happy to have you, Mr. Dewerson. So, how can we use these new data types we have here, to make our game better? Well, for one thing, we have this list now. We know about lists. We could, instead of having a simple flag of whether or not the player has a key, let's go back to our game. I think I need another notepad, too, to be honest. Let's open the notepad again. There we go. Let's open up our adventure day 1. That means we have to go to our documents, then go up a directory, go to, I'm sorry, I fucked that up. I did fuck that up, that's fine. Let's go here, users, blah, 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 Venka, learning Python, right, that's where our folder was. And then we're going to, I have to show the document, right, I'm stupid. Okay, let's show adventure day 2, that's what we're working on right now, right? Did you just use an Iswoogie emote? I don't know if I did. I don't know what an Iswoogie emote is. So, in our game here, our very simple adventure game, we have this flag. Does the player have the key? Well, it's false at first, right? It's false. Why don't we add a new command, first of all, right? Let's just say, we have a key, and what else do we have the player can grab? Maybe a torch. That's pretty basic adventure game stuff. Faceless, huh? This swooey emote. Let's give a new thing. Let's make a new flag here. How about player has torch? It starts off as false. Right? But when we examine the cave, right, look around, let's add a torch here. So it says, the cave is dank, there's a treasure chest. Then let's print off. There's also a torch. Right, so now the player knows when they look around the cave that there's a treasure chest and a torch. Well, now we can give them a new command to use. Why don't we give them a command, for instance, right here. Doesn't really matter exactly where. In fact, to be simple, let's add it to the end, right here. Elif player command equals, get the torch. Let's, run a new function called, get the torch. We haven't written that function yet. Let's go write that function, shall we? So here we're calling a new function. You can tell it's a function call because it starts off with a word, the name of the function, and then parentheses. That means you're calling a function. We don't have that function. It doesn't exist. Let's go make it. Let's do it right here. So let's just define, get the torch. And then we're going to just print off, right now we're going to make it very simple. Just, you picked up the torch. There you go. So right now, we have bugs already, guys. You guys have been following along. You probably realize we have some pretty bad bugs here. But here's what's going to happen, basically. We have a new value called player has torch, right, that determines whether or not they have the torch. We have a new command we just put in the game. Get the torch. All it does is it runs get the torch. It runs a little function call there. And the function call, all it does is print off a string. You picked up the torch. Let's try it, shall we? Let's see what happens here. We got mad bugs, I can already tell. You guys might not be able to know that. You guys might not be able to tell. You fucking noobs. Alright, so let's see here. You're in a cave. Let's do a dance. Okay, that still works. Here's our problem, guys. Let's get the torch. Okay, well, it gives me some text, right? It says, you picked up the torch. Alright, that's what we wanted, right? That happens right here. So we used the command, get the torch, and it ran this function, get the torch, and then it prints off this string. You picked up the torch. But nothing else in the game has changed, right? Our player has torch flag is still false. In fact, get the torch doesn't even check that flag, nor does look around, right? So even though I just picked up my torch, if I look around, it still says there's also a torch. All right, let me get the torch again. I picked up the torch. Let's look around again. The torch is still there. Let me get the torch and get the torch and get the torch. Right? Nothing's happening. It's just printing off data for us, right? It's just printing off some string. There's nothing in the game actually changing. So let's make it more interactive by using this flag we made, right? We made this flag, this boolean value. A player has torch. Let's use it. So first of all, when you try and get the torch, it should feed the game whether or not you already have the torch. So let's give it an argument. Player has torch. Right, so now we can feed in an argument here. We can feed in some data to our function. And we can say, if player, if not player has torch. So we talked before about how the word not, it reverses the value of a boolean. So we're saying, player has torch is true or false, right? We're saying if not player has torch. So, if it says if player has torch is false, so at the start of the game they don't have a torch, right? We're saying if not false. So if true, run this. Right? So we're saying, in other words, we're saying, if the player does not have the torch, right? If not player has torch is if the player does not have the torch. Then we can give them the torch. Thank you for the follow, somebody. I'm not sure why I can't see up there who followed me. I apologize about that. Let me actually fix that right now. I fucked up. Think about fucked up. Thank you, Homeless Waffle. That's kind of a sad name. Homeless Waffle. Thank you for the follow, Kinmag. Excuse me, Kimmag, not Kinmag. by the way, guys. Zanzu says, how can the player see if he does not have the torch and it is lit up already? Doesn't that mean someone was there before him? All these questions I have about our protagonist. We can answer these questions in time, Zanzu, in time. We got plenty of time to make this game as cool as we want. Right now, it's still very simple. So we're saying, hey, listen, if the player does not have the torch, right? So if player has torch is true, then, we kind of reverse that value. Then we can give them a statement. You picked up the torch. Okay. Then we can say, else, if the player does have the torch, print off, you already have the torch. Dum-dum. Right? You idiot. Why are you trying to grab the torch? You already have the torch. Stupid. But if they don't have the torch, we have to change this flag. Right? Player has torch. Now becomes true, because now they picked up the torch. And then we talked before about how functions are like Las Vegas, right? What happens in a function stays in a function unless you return that data out. So we change this value here. Player has torch is true now, but that's only true inside this function. Let's return the data out now. Return player has torch. Right? So now at the end of this function, whatever the value is of player has torch is spat back out of the function. Arguments, like this one, are how you get data into a function, then returns how you spit data out of a function. So now we can go down here, we can say, get the torch. We can say player has torch equals whatever gets spat out of get the torch. We have to feed in some data too, right? A new argument here. We have to feed in player has torch. So basically what we're doing here, when you run and get the torch, we are running this function, get the torch, but we're feeding it one piece of data, which is the current value of whether or not the player has the torch. That's one thing this thing needs to work. Right? So when we try and grab the torch, we tell the game, first of all, the player has the torch already, or they don't have the torch, right? So then the game can run its code based on whether or not the player has the torch. So if they don't have the torch, then go ahead and grab it. If they do have it, call them a dum-dum. Then it returns the new data out of whether or not they have the torch now. Right? So when we started the function, they may not have had the torch. Once it's over, now maybe they do have the torch now, right? They grabbed it, right? So now we can save that new data back to our flag. Right? So now maybe it's true that he has the torch. Now we can save that to our main game. Right? Cool beanzos. Likewise, let's go change our function up here. Right? Look around. It prints off there's also a torch. Right? However, that might not be true. Right? So now it needs some data here. We need to feed in some data. We'll feed in player has torch. Right? We have to say, if not player has torch, if they don't have the torch, then print off there's a torch there. We can say else. So if they do have the torch, we can say, there's an empty spot where the torch was. Right? So we have this, else statement here. If the player already has a torch, then there's an empty spot where the torch was. Right? Cool beans. Now, unlike our other functions, so if you look at get the key here, it returns the new value of player has key. Right? Because maybe the player grabbed the key by using this function. So something might have changed. Right? So we actually return the new value of player has key. Likewise, we have get the torch, we return player has torch. So it gives us some data back. We feed it some data in, and it gives us data back. Right? We start this function with the player having the torch or not having the torch. Then by the end of the function, that may have changed. So go ahead and give us data back. Does the player have the torch now? Return that data for us so we know what's up. However, look around, it doesn't change anything. It takes data in, it needs data as an argument. We have to know if the player has the torch to give them the right description of the room. However, it doesn't actually change whether or not the player has the torch. It doesn't change anything. It just shows us some strings. So we don't have to return any data here. We can just do return, right? Return with no there's nothing here. Just return. All that does is end the function, and it returns no data. Right? It returns none. But we don't need that. That's actually implied in Python. When your function ends, it just has it's the same thing as return nothing. So that's fine. We're not returning any data there. Cool. So let's look at our function now. So now we've actually improved our game quite a lot. Now it actually matters whether or not we have the torch. Now we can grab the torch, and once we have it, we can't grab it again. And once we have it, we can't see it in the room anymore, right? Because it's in our hand. So let's see if our code works. I may have actually got some typos in there. Who knows? Let's control pause to kill the program manually, and then hit up and run the program again there. So now I want to get the torch. Let's look around first. I'll look around. Oh, I made a typo here, right? Missing one argument. Oh, I see. So it's missing an argument here. Player has torch. It says type error. Look around, the function we wrote, is missing one positional argument. Player has torch. It's on line 59. Well, we don't have any line counting in Notepad, but I know where it is. It's down here. So I entered this command, look around. And it ran this code, look around. But there's no argument here. Right? It's just an empty little parentheses there. We had this error because now we recoded we rewrote our program so that look around requires an argument. It needs to know if the player has a torch. Let's go feed it that argument, shall we? That'll solve our problem. So we need to feed it this data, whether or not the player has a torch. There you go. That should work now. That was our problem there. I made a boo-boo. Let's try that again. Boom. Let's look around. Hey, now it works. It says the cave is dank. There's a treasure chest. There's also a torch. Let's get the torch. Okay, I grabbed the torch. Look around again. Hey, there's the empty spot where the torch was. Now it works. Let's get the torch again. Because we already have the torch done. So now we actually have this torch. Right? So now the game is actually changed around what we've done. We've made the game interactive. That's pretty sick. You gotta admit, it's pretty sick. But what's really doing here is it's changing this Boolean value, this true or false value. It's changing it from false at the start of the game to true once we get the torch. And then a couple of functions like look around and get the torch are then using that Boolean value of true or false to decide what text to put on the screen. Right? So if it's false, then print off when we look around, there's a torch on the ground. And if it's true, then print off there's an empty spot there. Right? It's really very simple. It's just using this Boolean value. But I want to utilize our new data types to make our code a little bit neater. So look at our data types here. So here's what I'm thinking, guys. Now the game has two kinds of things we can pick up. It's got keys and it's got torches. Instead of having a bunch of true or false flags, like, like player has key, true or false, or player has torch, true or false, or player has sword, true or false, or player has scroll, true or false, like an endless number of Boolean values that can be changed. Instead, why don't we use a list to represent the player's inventory? Right? Because we described earlier that an iterable is a bunch of similar data. Right? It's not data that's like a name that's all one piece of data. It's a bunch of data. Right? It's not like, David, Steve Burt Hernandez. It's one name. It's more like, a list of things like yellow, brown, red. Those are colors. In this case, we're going to actually make an inventory. We'll go here to our program. Oh, we have these two flags. Right? Player has key, player has torch. Bye, fuckers. Fuck you, Boolean values. Let's use a list. Let's use player inventory equals an empty list. It's an empty list now. And we can add things to that list, such as a key or a torch. So now, instead of supplying this, get the key, instead of supplying it with a player has key value, we're going to supply it with a player inventory to check stuff out of, right, and put things into. Let's just say, a player inventory now, right? You have to check the inventory. And likewise for the torch, instead of supplying them with whether or not the player has the torch, supply them with the player's inventory to check if he has a torch or not. Right? Cool. And now we're not going to save this value anymore. We don't need player has torch anymore. We're going to save the player's inventory here. Actually, that's a bug. I'm going to explain that later. And here's another one. Get the key. We don't have this player has key value anymore. We have this player inventory instead. Right? We don't have, true or false player has key or true or false player has torch. We have an inventory, and you can check our inventory for us. Does the inventory have a key? If not, then give it a key. Right? So let's go see how this works now. So now we're supplying the inventory to these two functions, get the torch and get the key. And get the key requires you need to know if the chest is open. And we're returning a new inventory for the player. Right? whatever it was might get changed. All right, so let's go up here to our functions now for get the key, for instance. Let's just focus on get the torch for now. Get the torch, right? So for now, it takes a Boolean value, a true or false value. Player has torch. We're changing that, right? It doesn't require a Boolean anymore. Now it requires a list. Let's just give it the player inventory. And now this is not going to work anymore if not player has torch, because it's not a Boolean. This is a list. So here's what we're going to say. We're going to say if key, excuse me, if torch not in player inventory, right? Then you picked up the torch. Print off that data and then change this, right? We're going to say, how about we say, you know, player inventory. Wait for it, guys. It's going to be kind of scary here. Dot append, the function, torch. Oh, Lord. I'll explain that in a second, guys. I know. You guys are all lost now. Oh, my Lord. Then we're going to return the player inventory here. Okay. I know, Zanzu. Oh, my God. What the hell does this mean? We're going to do the same thing here with the key. All right, so here's the... I see another bug, too. I'll fix that bug later, too. Here's get the key. It doesn't require a Boolean anymore. Player has key. It requires an inventory to check. And here it says, you know, if chest is open and not player has key. Well, we don't have a player has key Boolean. We have a list now. Let's say if chest is open and key not in player inventory. Then print off, you picked up the key. Then instead of changing this Boolean value to true, we're actually going to change the inventory again. We're going to say player inventory dot append key. We're going to return this new inventory here. Okay, so we have bugs galore, but let me walk us through what changed, though. Let's walk us through what changed here. So one more time, we changed our Boolean values, that is to say the true or false values of whether or not we have the key and whether or not we have the torch, to instead having a player inventory, which is a list of things. And instead of asking, you know, does player have torch, yes or no, true or false, we're instead asking, is torch in this list, right? If torch not in player inventory, then run this thing here, append torch. I'm going to explain that in a second here. So, as you can see, we have a new comparison, right? A comparison operator. So, before we used mostly comparisons that were of two ilks, right? One is a number comparison. Let's talk about comparisons real quick. Let's talk about comparisons here. Our other document here. You know, actually, let's make a new document. Let's launch Notepad. Let's actually just make a new document here. Right, talk about comparisons. Call this, you know, simple comparisons.py. Basically, like comparison operations, any kind of operation where we're going to get a true or false value out, like a Boolean operation, right? So basically, here's what's going to happen. We talked before about, you know, we've talked about comparing integers to get Booleans, right? True or false. For instance, we can say, you know, 10 is greater than, you know, 12. That could be 10 greater than 12. So this here, this little character here, this little that little greater than sign, is a comparison operator. It gets a Boolean value back. So 10 is greater than 12. That equals false, right? Because this little thing here gives us a false back, because 10 is not greater than 12. And we also talked about, you know, excuse me. Oh, I can't type for shit. We've talked about comparing strings to get Booleans, such as, you know, we have the same name equals, you know, my name is equivalent to your name. So we can say, you know, my name equals David, and your name equals John. Right? So it compares right here. It says equals equals compares two strings to see if they're the same. So this also returns false, right? Because my name, David, is not equals equals, equivalent to your name, John. However, if I change my name to John, now this returns true. Returns the Boolean value of true. Because now my name is your name, right? It's the same thing, basically. Fine, all well and good. This is what we've used before. We've compared strings, we've compared numbers. But now we can compare lists, right? We can use, an operator to find out if some data is in a list. This is the in operator. So we can say, good pizza toppings. That could be a list. Right. It'll be, pepperoni, of course, classic. Ham, great on pizza. You need to have cheese, obviously. Green pepper is godlike on pizza. What's up, mutant? Welcome aboard, bruh. All great pizza toppings. Now we can say, pineapple is good on pizza. That would be, you could say, pineapple in good pizza toppings. So in is a operator that gives us back a Boolean value, true or false. That's going to be true or false. So pineapple in good pizza toppings. Well, is pineapple in good pizza toppings? No, it's not. So pineapple is good on pizza, that's going to be false. That's definitely false. Mutant says, guess who just booked his plane ticket to Michigan Masters? Oh my god, Mutant's going to be so fucking sick, dude. I can't wait, it's going to be in April. I wish it was sooner. Say January's Frosty Faustings. Michigan Masters. April. It's going to be so much fun, dude. It was so much fun last year. It was fucking huge, man. You should have seen that room. It was packed wall to wall with 3S players. Okay, so we've got this new operator we're using called in, right? And in returns a true or false depending on whether or not some piece of data is in a list. So let's go back to our game now and see how we're using it. Okay, so we're saying if the word torch, the string torch, is not in the player inventory list, then do this thing. Otherwise, if it is in there, then print it off. You already have the torch. Dum-dum. Cool beans. Now, what the hell is this line? What the hell is all this nonsense here? Player.inventory.append torch. Well, we have to talk about a couple things first of all. For one thing, we have to talk about this period here. To this point in Season 2 of Intro to Python, we have not seen this period yet. The fuck is this thing? Well, a period is, in programming syntax, similar to an apostrophe S in English syntax, right? So if I go over here to our simple compare, let's make a new function here, a new document here. Let's go ahead and save this first. We're going to save this as, what are we going to call this? How about like, simple ownership. So, in English, in the English language, apostrophe S, implies ownership. You can say like David's car. Exactly, KG. Friday night, append another beer. So David's car, that means it's my car, right? But, in programming, including Python, we use period instead of apostrophe S. Right, let's actually use we use this period instead of an apostrophe S to imply ownership. So what we're saying here is we're saying call this function. As you guys know, if you use a function, a name like this followed by parentheses, that means it's a function call. And we're giving it this argument torch. But this function append is not just like a built-in function like print or input, right here. And it's not a function we've defined, like up here, get the torch and leave the cave. This function that we're calling append actually belongs to this list, player inventory. So in Python, we're going to get more in depth about this next time on next Friday's stream. But basically, in Python and any object-oriented programming language, pieces of data like this list can own other pieces of data, and they can also own functions. And when a piece of data owns a function, it's referred to as a method, but they're the same exact thing. Method just means a function. I'm sorry, it's a little bit loud here. A method just means a function that's owned by a piece of data. So every list owns a function called append, and what it does, it takes an argument and it adds that argument to the list. So player inventory starts off as being empty, right here, right? We defined an empty list. There's no data. We know it's a list because it has these square brackets, right? But it has no data between those square brackets. It's an empty list. However, when we start appending data to it, we are adding things to that list. Let me demonstrate real quick. Real quick. So, we have this list, right? We have this list. It's empty, right? But we want to add some stuff to it. So we can say, we have this list. Let's print it off, right? Let's print off this list, first of all. So print off, we have this list, right? Let's run this code first here. There's an empty list now for us. Let's go here. I'm going to actually kill this program. It's control pause. Then we're going to run Python simple ownership.py. There we go. So we printed off our list. It's empty. Right? So it's an empty list. Zanzu, after coding is going to be some. It's going to be Mario Tennis Aces here. Parset says, "What the hell, Jesus? Is that you learn? Is that you that learn us of Python?" Welcome aboard, Parset. I don't know what that means. Welcome aboard, man. Mario Tennis Zanzu. So we start off with an empty list, right? But now let's append something to that list. Let's just say, we have this list dot append, a thing. Right, now we print it off again. Print off, we have this list. All right, so we start the program with an empty list, we print it off, then we append a thing to it, then we print it off again. Let's check it out here. Okay, cool. So it starts off, prints off an empty list first, then it prints off our new list where we've added a thing. You're totally right, Parset. You're totally right, dude. They are indeed mutable. That is dangerous. We're going to talk more about that in a future episode, though. The danger of mutability. For now, we're considering mutability to be fine. Mutability is fine right now, but next episode is going to be dangerous, guys. But yeah, right now it's fine. So basically, we have this list, and we add a thing to it. Now we have a list with one thing in it. It's a thing. Let's do one more. Let's add some more stuff. We have this list dot append, more stuff. And we print it off again. Print off, we have this list. Okay, so now our list has two things in it. It has a thing, and it has more stuff. So basically, when you run append, all it does is it adds things to your list. So I really like it to know. So you start off with the, excuse me, I'm stammering. We have the list's name here, right here. Then we use its append function using the dot syntax, and we add stuff to that list, right, as an argument. Kind of cool. Let's go look at how our program works now. Let's go re-examine our program. So basically, when you try and get the torch, you supply the inventory, and we find out if the torch is in the inventory. If the torch is not in the inventory, then we append the torch to the inventory. Right? Append just means add. It means add at the end, to be precise. So we're saying, if you're trying to get the torch, and you ain't got the torch, then here, have this torch. However, we say, if you already have the torch, then just print off that you're a dum-dum. Exactly, Zanzu. So let's go to the key here. Get the key. It also takes the player inventory as an argument, so you can actually mess with that here. And we're saying, hey, listen, if chess is open, and the key is not in the player inventory, then append the key to the player's inventory, and return the inventory here. Now, I'm going to explain a bug to you guys real quick. Well, let's we have a few bugs. Let's just actually run this code now and see if it works at all. Let's run our code here. And it seems to be working okay right now. Let's look around. Did we ever fix look around's code? It might crash the program if I do that. No, we actually didn't fix look around yet. We have player has torch. So let's not look around then yet. That's going to crash our program. Let's get the torch. Okay, so you picked up the torch. Let's try to get the torch again here. Okay, so we already have the torch. So that kind of worked. We added the torch to our inventory. So Sniper row, 14 row. I still feel really confused. I still don't know what is the result which comes out of all this work. Sniper row, I'm not sure I understand your question, bro. The result is we're making a game. It's a game like Zork. It's like a textual adventure game. You kind of give the game commands, and then the game interacts with you. You can walk around a cave. You can grab treasure. You know, you can open doors, that kind of thing. That's kind of what we're doing here right now, Sniper-O. We're making a very simple game, as an example here. So we have, we can get a torch now, that's cool. But we're going to crash the game by looking around here. Look around. That's one bug we have right off the bat. Okay, so name, player has torch is not defined. Thank you, I'm happy you feel that way, Sniper-O. Thank you for the compliment. It's a pleasure having you, Sniper. So yeah, so the name player has torch is not defined. That's because our look around function still requires our old, antiquated player has torch boolean. Instead, let's apply the player inventory. And instead of saying, if not player has torch, which is our old, our boolean, our old true or false value, let's say, if not torch in player inventory. We have this list now, right? It's not like a bunch of boolean values that represent true or false. Player has this, player doesn't have that, right? Now we have this list instead, which is everything we have. We have a list of stuff we have, and we check to see if this thing is in this list of what we have. That's how we get our true or falses nowadays. We say, hey, listen, I want this thing. Is it in your inventory? And it's yes or no, right? And this little in statement here gives us back a yes or no, or true or false. And if we don't have it, then, print off this thing. If we do have it, print off this thing. So that's one bug resolved. Also, we have this bug down here. Leave the cave. It still requires player has key. So does this here. We have this chest is open, player has key. Let's actually fix this right now. So if chest is open and key is in player inventory, there you go. Thanks for the follow, Sniper-O. We program here on Fridays. And we're more like a gameplay channel here, guys. We play a lot of video games here, a lot of Street Fighter, a lot of Metal Gear Solid, that kind of thing. Hitman. But on Fridays, we program. So if you guys see me playing Street Fighter, don't panic. We still program on Fridays at least. Thanks for the reminder, Zanzu. If I'm talking too slow for you guys, or too fast, this is actually our Season 2 of Intro to Python. Our Season 1 was programming Pokemon. That's on YouTube right now at youtube.com/Vencabot archive, or do a search on YouTube for Vencabot. You'll find me that way too. And you can go watch our streams where we started off just like this, very basic in Notepad, learning what a variable is, learning what a function is, what an argument is. And then by the end of our series at 6 episodes, we had a fully working version of a Pokemon battle where we could actually make our own Pokemon and have them fight and make our own moves. It was very cool. Right now we're back to basic. This is our second episode of the new season, which means that we are kind of getting more advanced here than we were last time, but it's still nowhere near as advanced as we're going to be getting in the following weeks. But yeah, so now we need to fix this function here, where it still needs the player has key. Yeah, thank you, Zanzu. And we still have this player has key boolean here. Instead, let's give it an inventory, a player inventory. And now we're going to say, instead of saying if player has key, true or false, we're going to say if key is in the player inventory. There you go. I think that should fix all of our overt bugs, all of our bugs that are really going to crash our program. This should be okay now. Let's actually run our program and test it. See if it actually works completely now. Okay, so we're in a cave. What do you want to do? Let's do all of our commands that we know, right? Let's look around exactly. Look around. Oh, thank you, Zanzo. I still fucked up. That's what Zanzo's trying to tell me there. It still needs player has torch there. I'm stupid. Let's go up here to look around. Okay. Where does it need that at? Oh, down here. Down here. I see. I didn't apply it, its correct argument down here at the bottom. So here we are at the very bottom of our code, guys. We're actually checking our commands. Here we fixed the functions on top. We fixed the way the functions work, but we did not fix the way that they're called, right, Zanzu? We fixed how they work, but we're going to call them differently, too. So instead of saying open the chest, chest is open and player has key, we just apply it with a player inventory. And likewise, instead of looking around player has torch, we supply the player inventory. There you go. Zanzu totally knew that, Kappa. Likewise, right here, leave the cave. We don't use a player has key anymore. We actually use the inventory to see if they have the key. So give it the inventory. There you go. Okay. We fixed it up top, but we haven't fixed the way that it's actually called. Now it should be working okay. Let's try it again. Boom. What you want to do, we're in a cave. Let's look around the cave. Okay, so it says the cave is dank and there's a treasure chest. There's also a torch. I think we did get the key, actually. Let's go double check that before we actually run it for Zanzu. Let's go up here to get the key. To get the key uses the player inventory, right? So that's what we want. And we check the inventory here, and we check the inventory here. So it looks like get the key still works. Let's go check how it's called down at the bottom. So if the player command is get the key, then give them the value of chest is open, and give them the player inventory. That's correct. Okay, so we're all good there too. So let's let's try to get the key right now. Get the key. You don't see a key. Okay, that's cool because the chest is not opened yet. Let's open the chest. Okay, you open the chest. There's a key inside. Okay. Let's open the chest again. The chest is already open. There's a key inside. Let's get the key. Okay, it says you picked up the key. All right, let's open the chest. It's already open and it's empty. Okay, so that works. Hey, what's up, here goes? Valle too strong. I'm so distracting, dude. I can't think about programming anymore. I can think about his Valle's beautiful smile. All right, so let's we have the key now. Let's do a dance. If we're happy we got the key. All right, got a break dance. Good shit. And then let's leave the cave. Game over. Okay, so we beat the game, guys. In this game right now, the way it works is all you do is you enter the cave, you open a chest, you get a key, you walk out of the cave. That's the whole game. Let's actually get the torch too. Let's look around here. Okay, there's a torch there. Let's get the torch. Okay, you got the torch. Look around again. Now it's an empty spot. Let's try and leave the cave. Okay, we can't leave the cave. We don't have the key yet. Okay, open the chest. Get the key. Leave the cave. Beat the game. Easy-ass game. Here goes, says, I'm starting holiday hours at my job so I can finally stick around for Metal Gear Solid. Let's go. Metal Gear Solid. I had a lot of fun last night playing that game. All right, so now our game is fully working again, but we still have a bug that's not immediately apparent to us, but it's something that one of our friends mentioned earlier, one of our new friends here. I forgot what the guy's name was. Let me go double check here. It was, oh yeah, Parset. Talked about how lists are mutable. Let's talk about that real quick, what it means to be mutable. So here's our bug, guys. It doesn't actually break our program at all, but it is still a bug. We have this situation here where anything that messes with the inventory, like get the torch will mess with your inventory, right? And get the key will mess with your inventory. We supply the inventory as an argument, and then we return that inventory again, right here. And then we save the new inventory as player inventory. Now, this is how we have been approaching programming, approaching functions, I should say, to this point. I mentioned earlier that to get data into a function, you give it an argument, and to get data out of a function, then you return that new data. Then you can assign that new data outside of the function, like right here. We talked about that before. However, it's not entirely true. I said before that what happens in a function stays in a function, but that's not entirely true. And we have this concept called mutability or immutability, right? And mutable means like mutatable, like you can make it mutate, right? Things mutate. So far, let's go back to our simple, let's go back here to ownership. Let's actually open our thing about data types, simple data types. Okay. So before we talked about integers and floats and strings and booleans, right? So in our first episode, we had these 4 kinds of data, right? Which are 2 kinds of numbers, text, which is a string, and a boolean, which is true or false. These are all immutable types of data. They cannot ever be mutated. They're always the same. As soon as you define them, 1, 1.5, hello world, true, they always stay that way. You can't change this string. It is forever going to be hello world. However, you can fuck with that string, if you're into that kind of thing. You can chop it up and resave it as something else. But whenever you resave that data, like for instance, like knows Python, right? Knows Python, we could make that into false, right? But this true value does not become false. It's just that we make a new false and then we assign knows Python to that new value. It's kind of hard to understand if you're not really like a long-time programmer. It's like, imagine if, I could never, learn a new video game, right? But I want to learn a new video game. So instead of learning a new game, I just make a clone of myself that knows how to play that video game, and then I vanish, right? So I can never learn that game, but I can copy myself and mess with that copy, right? That's kind of what we've been doing so far. We've been, instead of changing data, we've been copying it and altering it, right? Whereas lists are different. Lists actually can change. They are mutable types of data. So that means that even though we're adding things to this list, let me go back to our example here. We want to look at Python files, simple ownership. When we use this list.append, I'll lower the volume here a little bit again. When we use this append function that belongs to this list, we are changing that list. We're not making a new list with a new thing in it. We are actually changing the list itself. So that means that we don't need to return data anymore. Let me show you an example. Let's come back to our program here. So basically, we feed in this list to get the torch, right? It gets this inventory, which is a list. And we actually append this torch to the inventory here. And then we return the inventory, the new one, so that we can save the inventory. The new inventory here. But that's the fallacy. There is no new inventory to save. It's the same one it always was. So really, we don't need this assignment here. Or here, get the key. Because the inventory itself is being altered. Likewise, we don't even really need these return values here. Because we don't need to return any data. The data is being changed inside the function, and it's being changed permanently. Sniper says, I'm really sorry for being rude, but I still want to see a real result. Even in YouTube, I didn't find anything that I can deal with as a game. Sniper, the episode 6 of our Python example, our Pokemon example, should be a working game for you. But indeed, Sniper, we're not making like a fucking, we're not making like Battlefield. We're not making something like The Legend of Zelda. We're basically working with very simple ideas for total beginner programmers. That means no graphics. So if you can't handle games that have no graphics, then this is probably not the stream for you. We're working mostly with textual games. Any kind of game we can make that we can use the very simple Windows command prompt to run, because we are beginners here, right? We're all beginner programmers. And doing things like graphics takes a lot of time and expertise and a lot of work for a beginner especially. All of our games here are very simple. They are indeed games though. No, here goes, calm down. He's not really a sniper. He's not really a sniper. He's a friend of ours here. Okay, so we don't need to, unlike when we return this these Boolean values, right? So we change this Boolean, we feed in a Boolean, and we get a Boolean out, like adventure is ongoing, right? And we return the value. This value has to be returned because we can't change it inside the function and have that change be reflected outside of the function. What happens in the function stays in the function, right? We feed in some data, get some data out. However, that's not true of mutable data types, data that can be changed dynamically, like a list. So a list, we can feed in a list to a function and change that list inside the function. And then even outside the function, that list is still changed because we have not made a new list inside the function to mess with. We have actually changed the existing list. And that's only true of data types that are mutable, such as lists. And later we're going to find out that dictionaries work the same way, or mapping types. Exactly, Zandu. We're making games that are more like examples. They can be kind of fun to play. They're very fun to develop, but they're not meant to sell or anything like that. They're not like commercial games. Typically, you won't find one man who is new to Python making a commercial game in a week. Vencabot, I'm going to code Slam Masters 3. Maybe one day, dude. So we're going to be moving to much more of a programming focus on the stream here in January. Who knows, but the sky's the limit once we hit January. It's going to be programming every day then. Okay, so before we move on, let me review very quickly what we learned about mutability here in simple ownership. Let me just put some notes for you guys to read here. Yeah, thank you, Skullcrusher. I appreciate that support, dude. That link there. Welcome aboard, man. He's got the hook up there for Sniper Row. I'm still waiting for that Battleship 8-player multiplayer game one day, dude. I want Alex and Hugo in Slam Masters 3. That'd be a really sick crossover. All right, so let's make some pretty quick notes here. Quick notes about mutability. Right. As a final review. Many types of data cannot be changed once they're defined. These are called immutable data types. They can't be mutated. Right? They're immutable. They can't be mutated. Immutable data types include, integers, floats, strings, and even tuples. Booleans. Right? They can be defined, and their name, their variable name, can be reassigned, to a new value. However, the underlying data itself cannot be mutated. It can only be defined and discarded. Right? So for instance here, we have this, Boolean, example Boolean. It equals true. And we can assign its name to false. Right? Now it's false. Easy. So it was true, now it's false. However, this true did not become a false. Right? It's just that the name, example Boolean, was assigned to some new data. Right? And now, because this true is not being referred to anymore by anything, that true goes bye-bye. It just vanishes. What's up, Bones? Welcome aboard, man. It's not a crossover, because Slam Master is the earliest point in the Street Fighter timeline. Really? Is it in the same canon? Straight Boolean on Mars. It's Python night, Bones. It's Friday. Crazy how time flies. Right? So we have these immutable data types, right? So we haven't actually changed true. It suggests that now it is, the same name, example Boolean, has been assigned to a new Boolean, false. However, immutable data types include, lists and dict and, a bunch of other objects. These data types can be changed they can be changed, at their core, right? They can actually be changed, and you don't need to discard them. You don't need to, discard them. Just go, right here. Whenever you want to update them, right? Unlike this one here, where we actually discarded the true to replace it with false. Lists, they actually can be updated, and the list itself can change. I know that. Here goes. Wow. Street Fighter trivia in the chat. So, we have this list, right? We can say, a list. And it can equal, we can give it like, a thing and something else, right? And then we can say, a list.append one more, thing. And now a list has changed. This actual list here has actually changed. We haven't actually made a new list that has 3 things and then got rid of the old list. The old list has actually changed. I know that about you, Here Goes. I know you're a lore fiend for Street Fighter. Okay, so what does that mean for our program? One more time. That means that when we feed in this list to a function, we can change the list inside that function, and then the actual list itself has changed. So no matter where else you use that list in your program, those changes are reflected. So we can actually change the inventory inside of a function, like get key or get torch. And then no matter where else we use player inventory, it is now updated with those new values, like the new torch or the new key. Whereas before, we had to actually return data out of a function to update, the actual game itself, because we couldn't just feed in data and change it. We had to feed in data and get data out, so we could actually, update. We could actually change the assignment the name assigned to that data, right? Because we never actually changed data. We just assigned different names for the most part. But now we're actually playing with mutable data. I'm sorry, guys. I'm getting a little bit abstract here. We should focus more on making a cool game. Thank you for the follow, Garrus1. I'm sorry, guys. Again, we're getting a little bit more abstract than I'd like to get here. Let's focus more on utilizing concepts for a purpose. In this case, a game, right? Not so much about what everything means in the nitty-gritty. This is what you got to know about this game, right? What you got to know about this game is that we have two flags now. They're two boolean flags. Chest is open, and adventure is ongoing. And then we have this inventory, which we can check for stuff. Right, we're checking this inventory for stuff. And we're adding stuff to the inventory when we get the torch and when we get the key. And we're checking the inventory for stuff, such as when we are, opening the chest. We can figure out if the player has the key or not. Oh, look at this. We've got a bug here. We have player has key for open the chest. That's not good. It needs player inventory. So get the key, open the chest. Needs a player inventory. Not player has key. We got rid of that. We say, if not chest is open, there's a key inside. And if not, instead of saying player has key, our old boolean, true or false, player has key, we're gonna say if not key in player inventory. There you go. That's better. Okay. So basically, we can change the inventory by getting stuff in our game, and we can check the inventory for things like looking around a room, what's still inside the room, right? Or maybe you want to open a door. Do you have the key? In fact, why don't we add a door, as they'd say in Canada, a door. So why don't we, make a door? So let's just say, if you look around the room, the cave is dank, and there's a treasure chest, and also there's a door. There's also a door. Or if you're American, a door. Yeah. Open the door. Open that door. Okay, so we have this door that we have now. But the door, we don't interact with that door yet. Let's actually interact with the door. Let's have Arcsum. We define that there's a door there. You can see the door now. But what do we do with the door? Well, we can open the door, right? Let's make a new function. Open the door. We're going to print off, the door's locked. Dang it. Right, you can't open the damn door. You want to open the door, you can't. Use scrub. I'll actually add the command down here too. We're going to say elif. I'm sorry, this is musically a little bit resonant for my tastes. Let's say elif player command is equivalent to open the door. So if I type in open the door, run the function open the door. Right, there you go. So we have a new function, a new door. Let's go try out our new door. What you want to do is look around. Hey, there's a door there. Cool, that's new. Let's open the stupid door. Ah, fuck. The door is locked. Fuck. Fine, let's just quit. I give up. I can't open that door. It's impossible. So, we have a door now, and we can't open it because the door is locked. Why don't we make a new flag, right, for our game, a new value. We're defining all of our values here. Let's define a new value for, like, door is unlocked. Right, that's false. Starts off false. The door is locked still. The door is not unlocked yet, so that's false. Okay. And now when you try and open the door, you have to figure out if the door is locked still. So let's feed it this value, right? Feed it the value of door is locked. Or door is unlocked, excuse me. It's very mysterious, Bones, all right? These pink diamonds. Don't think too much about it. Don't think too much about it, guys. It's going to blow your mind. Some things are beyond mortal ken. Some things are beyond mortal ken. So open the door. We have to find out if the door is locked, though, first. Right, so let's go up here and supply this value here to open the door. It needs to know if the door is locked. So it's a door is unlocked. It's going to be a true or false value here. It's okay, Bones. It's a pleasure having you, man. Let's go, Kenny. Kenny also a VIP. He's one of those guys. So we're going to say, you know, if, you know, not door is unlocked. So if the door is locked, say the door is locked. Right. However, we can say, you know, else, so if the door is unlocked, print off, you know, you open the door. We should probably return a new value, right? We should return a value about whether the door is open or not. In fact, probably need a value to know if the door is open or not. So let's say, you know, if the door is unlocked and if the door is open, we say, hey, listen, you know, if not door is unlocked, then we say the door is locked. Well, we say, you know, if the door is locked, then it's locked. Put it that way. Then we can say, you know, elif door. How about say elif? You know, so if the door is unlocked, you know, is the door open? Elif not door is open. Then print off you open the door. Or the door is not open. The door is unlocked and it's not open. Print off you open the door. Finally, we say else. You know, the door is unlocked and it's already open. Print off. You know, it's already open. The door is already open then. There you go. So we need another value, right? We have this value door is unlocked and door is open. We need another value. So we have the door is unlocked is false and door is open starts off as false. If we code it together, guys, it'd be a lot easier. I would like to, starting in January, guys, we're going to be actually doing more programming streams around here. Right now we're doing programming on Fridays. Starting in January, it's going to be like almost every day. I hope at that point we can actually program together, not just have me be lecturing to you guys, but rather have us work together on a project, a very simple example, and we can answer questions in real time that way. Yeah, thank you. I appreciate that, Bones. I appreciate that. We're trying our damnedest out here. Okay, so now we have this door is open value. It's false. Starts off as false. So why don't we feed that data into the open the door function? Door is unlocked and door is open. And then also it returns a new value. Maybe the door got opened up, right? We're going to say, you know, door is open is whatever's returned by open the door. Right? So we're going to say, you know, open the door. It has to check if the door is open. And then we can actually change the value of open the door, right? So we're going to say open the door and then change this to door is open is now true. And then we can say return the new value of door is open. Right? I code third strike 2, let's go. Maybe one day. Yeah, I'm not sure we're going to make, right off the bat, like some real serious games. Really, my focus is going to be tutelage. I'd rather have, like, some people that want to learn to program, and they want to come by in this time slot and work with me to learn how to program. Right? They can ask questions, they can, you know, try to find their own solutions to problems. And I can sort of supervise and offer advice, and maybe even code alongside them as a way to learn. I feel like I love lecturing, but at the same time, I think it could be more effective if we sort of work together. Can hold me to that. I should have been putting 40 in a month. I owe you dudes, huh? I'll be finding funding, I think. Jazzy number 5 solo, I think. Wow. Is this what you studied for? I'm not sure I understand the question, Bones. I have not studied for anything. I'm actually a high school dropout. I'm uneducated. Okay, so we have this value now. The door is open. We can actually change that value if the door is open. So let's try and fuck with it now. We have a problem already. Let's go try it anyway. Coding, I wouldn't say it's a... Yeah, it's a hobby, yeah. I'm a hobbyist programmer for sure. I've been doing it for about 20 years. Okay, so what you want to do, I want to open the door. But the door is locked. The door, I can't unlock the door yet, right? There is no... Let's unlock the door. Okay, you can't do that. Well, what does that mean? That means that we don't have the command in the game yet. So why don't we make that command next? We have a door and it's locked and we can't open it. We have to be able to unlock the door, right? Let's make another command here. So the player command is unlock the door. We have to run this function, right? Unlock the door, which does not exist yet. Doesn't exist yet, right? Well, what's it going to need to know? It's going to need to know if the door is locked. All right, so we're going to say, you know, door is, door is unlocked. Right. So if the door is unlocked or not, then we have to know that when we try to unlock the door. And it's going to return a new value, right? It's going to return whether or not the door is locked. Because it could unlock the door for us, right? So we're going to say door is unlocked equals whatever comes out of unlock the door. And so Bones knows the struggle. Here goes, I barely graduated high school because of how much I hated school, but now I want to teach. And that's why you want to teach, dude. So others won't hate school so much. Alright, so we have to change the value of door is unlocked when we unlock the door. We have to feed it whether or not the door is currently locked. That way we know if the door is already unlocked, right? Let's go up here and make this new function. Define, unlock the door. It's going to need to know if the door is unlocked already. So we're going to say, if door is unlocked, then print off the door is already unlocked. We're going to say, else. So if the door is locked, I'll say, how about elif? We need one more argument. We need one more argument. We have to know if the player has the key. We have to give them the inventory. Elif key not in player inventory. Right, if they don't have the key, we have to use not a variable name key, but a string key. So if they don't have a key, they're trying to unlock the door. Print off, you don't have a key. And finally, if the door is locked and they do have a key, print off, you unlock the door. You use the key to unlock the door. Right? And now we change the value of doors unlocked to true. True. Then we return the new value for door is unlocked. There you go. That should work. So here it goes, says, I want to engage my students more, huh? For a lot of teachers, they treat it like sit down and shut up instead of trying to actually reach the kids, huh? So Bones refused to understand advanced math. He got 70 plus and everything else, huh? But math was 0. No graduate. Go school system. Okay, so now we have a new function here, unlock the door. It takes two things. Whether or not the door is unlocked already, and the player's inventory. We just apply the inventory down here, right? Let's go do that. Boom. Now it should work. Let's try it. Kill our program as it stands now. So Skull says, do you think students are mature enough to give a shit? I've seen decent teachers just get jaded by the immaturity of most kids. Hell, I graduated with, and my teachers hated me. I think that it's the teacher's responsibility to, you can say they get jaded and they kind of give up, but no, they gotta do their jobs. They gotta do their jobs. Okay, so let's see here. I agree that some kids are, some kids just won't learn. They don't want to learn. But that being said, it is still a teacher's job to try their best to reach them. Okay, so what do you want to do? I want to look around first. So what, we got a door and a torch and a treasure chest. Okay, cool. We have a more complex game here now. Holy shit, we got a lot of things going on here. So let's open the door first of all. The door is locked. We can't open the door. Let's unlock the door. I don't have a key. Let's get the key. Okay, I don't see a key. Let's open the chest. There's a key inside. Okay, let's get the key. I got a key now. Let's open the door. The door's still locked. Let's unlock the door. Okay, I used the key to unlock the door. Now let's open the door. Hey, open the door! Look at us. Holy shit. The chest was a mimic. Game over. That'd be sick. That'd be a sick ending. That'd be a classic adventure game ending right there. Math was my first class in the morning, says Bones. How the fuck they expect a kid to do basic calc at fucking 8:30 in the morning, huh? Skull says Spanish was my first class at 7:30 a.m. No bueno. Wow. Here goes, one of the best teachers I ever had would constantly use YouTube videos and current memes to get the kids into history. Man, how young are you here? You're a pretty young guy, right? Here goes, holy shit. When I was a kid, there was no such thing as a meme. Okay, so, not widely known anyway. So, our game is That's really young. Our game is really involved now, right? We have a bunch of variables at play. In fact, you can even see that in how complex it looks. It's getting to be quite massive, maybe even beyond readability, right? And this is why we grow as Python programmers and as programmers in general, because there is more to writing a program than making it work. Right? There's more to it than making it work. A big part of writing code is knowing how to do it efficiently and how to do it in a way that's elegant, which means to say that it's easy to understand from looking at it. And our code right now is getting a little bit sloppy looking. It's a lot of different function definitions here for doing stuff, and a lot of different commands. Look how long this command tree is, right? We ask the player for command, and then we say, if this, do this. If that, do that. If that, do that. Over and over and over again. It's kind of involved. Arkham says, very bueno. Go get laid, dude. Don't waste it on Twitch. You'll still be doing this in 10 years. What's Bones talking about? I was an alcoholic when I was 20, huh? I certainly think the next age of teachers is going to heavily involve YouTube and shit, maybe even Twitch. I wonder. Maybe something like Twitch. Okay, so it's getting a little bit sloppy here, our code, but it does work though. It does work. It's getting the game is more involved now. We actually have kind of some cool objectives here, right? We can actually try and open a door, get a key to open that door. We have that curiosity factor going on to kind of compel us to see what's behind that door. But as our game gets more complex, it becomes more difficult to manage. Now, as this series goes on, we're going to be taking this working code and making it more elegant. We're going to be making it a little bit easier to understand, a bit easier to add to. Because right now when you're adding new features, it kind of is a pain in the ass. We have to add new flags. We have to add new commands. We have to add new functions. It's kind of tough then to add hundreds of new features, right? But if we are smart programmers, we can actually make that a lot easier. And we'll do that in the future by using things like classes, inheritance, object-oriented programming, and things of that nature. Right now, though, there's one thing I think we can do right off the bat, and that is to use dictionaries to make our code a lot more efficient here with these commands, right? I'm not sure. It's kind of an advanced idea. I'm not sure I want to get into this. We've already kind of gotten a bit more complex than I would have liked here. I feel like our first series for Pokemon had a much more stable progression. We kind of jumped ahead pretty far here, pretty quick in adventure games, in this Zork example. But why don't we look at a way to simplify these function calls? Now look at how we're handling this right now. Right, right now we're handling this, every function call that returns new data. We are running the function, right? And we're giving it the data that it needs. In particular, door is unlocked, right? For open the door, we have to know if the door is unlocked and if the door is already open to open the door, right? And then we get new data out of it, whether or not the door is open now, right? But wouldn't it be cool if every function that we had took the same arguments? That'd be a lot easier to understand, right? Because look at this. Every function takes different arguments. Look around requires the inventory of the player. And open the chest requires, if the chest is open and the inventory. Get the key requires, the same things. Chest is open and, if the player inventory. The adventure is ongoing requires the player inventory exclusively, but not the chest is open. Likewise, get the torch requires only the inventory. Door is open requires, to know if the door is unlocked with a true or false flag. Another true or false flag, is the door open or not. It's kind of a pain in the ass. Every function we've written takes a custom set of arguments. So here's my proposition, guys. Instead of giving every function different arguments, why don't we give every function a dictionary that will include the things that it needs? All right, what does that mean? Think about, what are you talking about? Here's what I mean, guys. What if, let's go look at our dictionary example here real quick, though. Simple ownership. I'm going to actually look at the data types. Open our simple data types example. we talked about maps, right, or a dictionary. And what we do with a map is we connect one piece of data to another piece of data. So here's my idea. What if we had this idea, right? You know, here's an example dict for our game. What if we had a dictionary that was called like game state that would save everything about our game in it? And we could have a dictionary that was like, you know, chest is open, right? It's a string that's associated with the value false. And we could have, you know, player inventory that's associated with a list of stuff, right? And we have this data called, adventure is ongoing, and it's associated with another boolean, true. So instead of using traditional variables, right now we're using all these things in a variable, right? Let's go look at that. Right now we're using all these things in variables, right? Chest is open is false. You know, player inventory is a list. Adventure is ongoing is true. But instead of using variables, why don't we use a dictionary and associate strings, which could be thought of as like variable names, with data. That way, every function can just take this dictionary as its argument. Then it'll always have every variable that it needs to run. Welcome aboard, Steve. So Skull Crusher says, kids already don't know how to deal with others as it is. Homeschooling won't help that. Kids need to develop more social skills with less self-entitlement. Boy, sounds like Skull Crusher's been thinking about this before, huh? I'd never think about anything like this. I would think about, like, you know, pretty things and things that shine and are glittery. Steve says, it sounds like you're asking quite a bit from me here. Where's that, Steve? It was goddamned a meat thresher 15 years ago, huh? You mean the school system? Steve never left, huh? Never left. Oh yeah, because Steve just leaves the tab open all the time. So I think we're going to come back to this idea next time for using a dictionary to save game state. Before we do that, let's talk about how to access data from our new data types, right? So we can come back next time for something. We'll come back hot. So we talked today about new data types, right? Tuples, which we haven't really used yet, but we have used lists, right, for our inventory. But how do you? We know how to put data into a list, and how to put data into a dictionary, and put data into a tuple. But how do we get data out? Well, you know, we know how to use lists. Let's actually make a new example down here. Let's just say, you know, how to access. Oh, if we're intelligent coders, I see. How to access data from our new data types, right? You know, we already know that we can test for data in a list using the in operator. That's mostly how we've been using lists so far, right? So we've basically been putting things in our list, our inventory, and then testing is key in the inventory. It comes back true or false. That's what we've been doing most of the time so far. But what if we wanted to, like, get a certain thing out of the inventory? Well, here's how you do it, guys. If you want to access a particular piece of data in a list, you do it by giving the list the index number of the data you want out of it. So, for instance, let's give an example here. You know, we can make a list again of cool guys list. Right? It's going to include Overlord Steve, obviously, pretty cool guy. It's going to include Bonza. Why wouldn't it? Should it include Skull Crusher? We'll give Skull Crusher there for sure. Yeah, we'll give Skull Crusher one. But it won't include Here Goes. Definitely not. He's not really that cool of a guy. But we want to access Bonza, right? Let's say we want to figure out a sniper. Let's put sniper in there for sure. That's fine. Sniper row, 14 row. Okay, we'll have another list here too. Yeah, we'll have a cool. We'll have like an all right guys. All right guys, we've got Here Goes. This is says thanks. Of course, dude. Here Goes. He's all right. We got Vencabot, he's alright. He's not that cool, but he's alright. Okay, so let's say we want to figure out who the second person in the cool guys list is, right? Who's the second cool guy? Sniper's a noob. Let's go team cool guys. To get data out of a list, to get data out of a list, we feed the list an index number. So we can say, you know, like, print. The second cool guy is, let me print off, cool guys, boom, square bracket, number 1, boom. That's already so confusing, right? It's pretty confusing. So here's what this does, right? We are getting data out of our list using an index number. So to do that, you use the list name, cool guys, and then square brackets. And between the brackets, you put in the index number. Now, an index number is kind of confusing because indexes in most languages, including Python and C++, JavaScript, they start at 0. So Overlord Steve is the first cool guy. That means that he is at index 0. Bones is the second cool guy at index 1. This is index 2. This is 3. Then for the follow Sublime, Otai. It's Otal, maybe? Sublime 0 Tal. I'm trying to understand. Welcome aboard, dude. In any case, we program here on Fridays. It's almost the end of our stream here, guys. We're going to end in about 20 minutes or so. And play some Mario Tennis on this channel. We're like a variety stream. We do a lot of gameplay on this channel, but on Fridays it's programming here in the first time slot from around 6 to around 9 p.m. Eastern. Welcome aboard as well, Dr. Octopus. Kind of a cool name, Dr. Octopus. You can use Python to make apps in Android. Yes, indeed you can. You have to use a special software for that, Sniper. I really focus, if you're learning Python for the first time, focus on making software for your own desktop computer. Later on, you can make Android software using Python for sure. Guaranteed. I know, here it goes, I know that. So, this is how you get data out of a list, right? Using its index number. And 1 is the second thing in the list, because 0 is the first thing in the list, right? So if you want the first cool guy, let's actually make another one here. Print, the first cool guy is, you can print off, cool guys 0. So the cool guy in the 0th slot. Welcome aboard, Dr. Octopus. Nice to meet you. I'm David, by the way. Yeah, so Sniper's really a beginner. Don't worry about mobile development, Sniper. Please don't. Focus mostly on making very simple desktop software to start off with. Kind of challenge yourself to make some little simple examples of code on your desktop. And then once you're comfortable making a your software on your computer, work on mobile. I'm glad you're enjoying it, Sniper. If it's too complicated, go check out our earlier streams. Again, they're on YouTube, guys, at youtube.com/VencabotArchive, or search on YouTube for Vencabot. You'll find me that way, too. We have some really simple examples on YouTube that start off more at the very basics. So right now, we're kind of an intermediate level, but our previous streams have been more basic. Thank you, Bones. So yeah, the first cool guy is in cool guy index number 0. And the second cool guy is in index number 1. Now, usually you don't usually access items in a list by their index, to be honest. Because usually when you have a list, you want to do two things with it. Usually you want to test to see what's in the list, like we've been doing. Like, is this thing in this list? Or you want to go through the list and do something to everything inside of it. Right, like print off the names of all the guys, or add all the numbers together, or something that does like something to everything in the list, right? You don't usually access a thing in particular, and that's true of tuples as well. So, tuples work the same exact way. So if we have a tuple, right? Like let's just say, what's an example of a tuple? Like a 3D coordinate, right? That needs an x, y, and a z axis, right? So we're gonna say, 3D coordinate. We're gonna have 12, 24. And 6, right? That's our tuple. And you can access, the z coordinate is, the 3D coordinate, the second index. That would be this right here, index number 2, the third slot, right? So the z coordinate is the third spot of your tuple. It's kind of like a list, right? Use the index number to access stuff. Sniper says, I found your channel, but still want to be here until the end. Good stuff, Sniper. It's gonna be a few more minutes here. So let's just get rid of all this shit then. This is kind of annoying me, all this data on the screen. So now we talked about using index numbers to access data in your lists or in your tuples. Again, those really don't come up that often, to be honest, using index numbers to access things in modern programming in Python. That happens a lot more often in other languages, or in older languages, using index numbers was much more popular. Nowadays, lists are mostly used for looping through, again, doing something to everything in the list, like printing off all the names or adding all the numbers together, or they're used for testing, is this in this list, right? But dictionaries, they're much more interesting to get things out of. Would launch this game after the episode. Would you launch the game? Hell yeah, dude. Yeah, if you want. Well, we're not going to sell the game, of course. It's an example. The whole point of this example here is to learn Python. It's not going to be a commercial-ready game. It's going to be a very simple game. I wouldn't say I'm not going to launch it, like to sell it, but I'll run it if you want. That's what we'll do. We'll run the program at the end of the stream. But let's talk about dictionaries, right? So dictionaries are a bit more interesting. So dicts are a bit more interesting, than lists or tuples. For one thing, instead of having index numbers, you access the values that are stored in a dict by supplying their key. What does that mean? Let's make a new dictionary for you guys. So what's a good example of a dict? We've made our favorite colors before, right? What's your favorite colors, guys? My favorite color? Let's see, Vencabot. Mine is blue. K-Reich likes blue as well. So we got K-Reich Jr. This man likes blue. Here Goes also likes blue. We're going to call him Here Goes. And Sniper, call him Sniper. He likes maroon. And Overlord Steve, I got Skull Crusher. We'll call him Skull. I'll have these all be lowercase for now. He likes green. Green. And we know Overlord Steve, he likes whatever color her penis is. Right. That's his favorite color. So let's lowercase all these. We'll call K-Reich just K-Reich. Take the junior away. Just make it all simpler here. I don't want to type in the full names of everybody. It's too much typing. Okay, so we have all these names, right? This list of this dictionary, right? It's a pretty huge dictionary. In fact, we're actually going to make it more readable by breaking the line here. There you go. So now we can actually make this a bit more readable here without having to scroll everywhere. Okay, so this is what we call a map. So Doc likes black. Let's put him in there too. So we have Doc Ock. He likes black. Cool. So Sniper, the reason you use 4 spaces is that it's a Python standard. Now, in Python, guys, the number of spaces you use is not important. It's actually, as long as you're consistent with it. So let's use an example here of like, a simple indent. Let's say, Python is cool is true. Or say if Python is cool, then print Python is cool. Right. So in Python, when you have code blocks, like this if statement here, you have to indent the code block. And as long as you use the same number of spaces for the entire code block, you're fine. So we can actually just use 2. Right? You could say like, print, I really like it. Or you could use just 1 if you wanted to, as long as it's the same for the entire code block. But there is a standard to use 4. That way, if you share your code with other programmers that like Python, then they can read your code more easily. So the reason why we all share 4 and 8 and 12 for, if you want to indent even deeper, is that it's a standard. That way we all kind of have the same look to our code. That's the main reason why you do that. In this case, I used 8 here for this. It's called a hanging indent, when you indent double deeply for things like long lists or long dictionaries. But yeah, so basically you want to do it in groups of 4, because that's just what Python programmers have agreed upon over the years. So please indent things in groups of 4. Please. Let's go back to our dictionary, though, our dictionary example here. So we have this dictionary, right? Favorite colors dictionary. Now we want to find out, we want to find out what, Sniper's favorite color is. How do we do that? Well, you know, if it were in a list, we could supply the index number. But this is a dict. Well, you know, it's a good thing it's a dict. The dict makes it easy to supply one piece of data, like a person's name, and get another piece of data out. Here's how it works. So we can print off Sniper's favorite color is favorite colors, our dictionary, Sniper. Okay, let's run this program here. We kill this other one here. Control pause to kill that program. So we're going to run our program now. We're going to run simple data types. .py. Why, I fucked it up here. Got a typo. I should put a quotation mark right there. There we go. All right. So Sniper's favorite color is maroon. So Sniper is right. How did he know? How did he know what his favorite color is? So here's how we knew what color it was. Because we fed the key Sniper into the dictionary favorite colors. Right? Favorite colors, Sniper. What this means is we say we want the data value that is at Sniper, at the location Sniper. And the location Sniper points toward maroon. Okay, now let's say you can say, you know, print, you know, Doc Ock's favorite color is print our dictionary favorite colors. We want whatever's at the value of Doc Ock. So what's at the value of Doc Ock? Let's find out. Black. Okay, so right here it says, you know, Doc Ock, colon. The colon means at this value is black. So what we've done here is we've made what's called a map. You know, a dictionary is also referred to as a map because we map one piece of data to another piece of data. So in this case, we're mapping a string, like a person's name, to another string, which is their favorite color, the name of their favorite color. Right? That's kind of cool. This is called the key. The key is like the location name, and then you have the value. So you have a key here, and a value, then a comma, then another key, another value, and a comma, then another key, another value, and a comma, and so on and so forth. So Skull says, is the first value always the key? Yes, indeed. Exactly, Skull. You cannot take the value and get the key back because the key is unique. As you can see here, Vencabot, K-Reich, and here goes. They all like blue, right? So if we said we want blue, like let's say, you know, whose favorite color is blue, we can't get one value back because 3 guys like blue. However, every key is unique. Right? Every key is somebody's name. We can't have 2 of the same name. In fact, if I were to go down here, right? Let's say I want to make like, you know, let's say there's another guy named Skull. Right? I have a friend on Steam on Twitch whose name is Skull. What's his name? Skull. It's not Skull Crusher. It's Skull something. Whatever. I call him Skull. I call him Skull. Right? And let's say he likes, you know, pink. Right? This guy likes pink a lot. So if I try and call for, you know, let's say right down here, print Skull's favorite color is, yeah, thank you, Steve. Skull Ripper, thank you. Skull Ripper. We have Skull Crusher and Skull Ripper. That's going to be favorite colors, Skull. What do we get back now? Do we get back green or do we get back pink? Let's find out. Maybe we get back neither, to be honest, but it's going to crash. Oh, actually, it gave me back pink. Okay, so it says Skull's favorite color is pink. That's because we took the value, the location of Skull, and we reassigned it. Right? So every key has to be unique. You can't save more than one key with the same exact value. Excuse me, the same exact data type as the key. So in this case, we have 2 different keys that are both the string Skull. The second one overwrote the first one. And likewise, we cannot call blue and get back a single name because the value can be the same for many different keys. Right? So the keys are always unique and the value can be whatever. However, there are, of course, hacks you can do. if you want to get all the guys, let's say for instance that I want to get all the guys who like blue, you can do something like, this is a little bit advanced. You can say like, for, it would be some kind of for loop, right? It would be for value in, let's just say, for key value in favorite colors dot items if value is blue, print key print likes blue. Right. So this will print off everyone's name who likes blue. So it goes through the entire list, the entire dictionary for every key item pair. So items means get the key item pair. Then it says, hey, is the value blue? If so, print off the key. That's one way if you want to get like all the values that equal the same key. Right. So if I were to do that, see it says, Vencabot likes blue, Kenny likes blue, here goes likes blue. Right. That's one way to do it. But really, if you're using a dictionary for its intended purpose, the idea is you assign a value to a key, then you use the key to get the value out of it. So dictionaries are very, very powerful tools. If you want to store data and get it back out again, you could think of them really being very similar to using variables, right? Like we could just have, we could say, favorite colors, and we could just have, Vencabot equals blue, K-Reich equals blue, here goes equals blue, sniper equals maroon, right? It's kind of similar to that, except that you're storing all of them in a dictionary. And what's crazy is that, and we're going to talk about this more next time, is that the key, it doesn't need to be a string. It could be any kind of data. So really, it's not really about associating a value with a name. It's more like associating two pieces of data together. Like, let's say that, you have a list of, cool guys and lame guys, and you want to know which is which. You can just associate that list with that, a function that handles only cool guys. It's basically, you can kind of associate things together quite freely with dictionaries. But to keep things simple here, early in our series, let's focus mostly on strings. They're very easy to understand. So dictionaries are kind of cool. It's kind of cool to get data in, get data out. They're kind of fun that way. So let's review things real quick here. So, to get data out of a tuple or a list, you use an index number, right? Such as, my list could have a bunch of integers in it, 1, 5, 6, 10, 80. Then you can say, a number, in particular, you want to get 80 out of there, that's index 0, 1, 2, 3, right? So that's index 3. So we can say, that's my list at 3. That'll print off 80. Likewise for tuples. And we can say, my name, right? We can talk about that earlier, right? It could be, David and Hernandez. Then you could say, last name is my name in index 1, right? That's 0, that's 1. So you can access data in a list or a tuple by using index numbers. However, dictionaries are different. Dictionaries use a key instead. So you can say, my dict equals, what's really cool, you could say, about, a Street Fighter, right? It's a fighter. You could say Dark Souls. That's an action RPG, right? You could say, Sonic. It's a platformer, right? Then if you want to figure out, genre, you can say, games, let's just say, games genre equals, my dict at Street Fighter. So now we can figure out what Street Fighter's genre is by putting in the key. You're right, here goes, you're right. So, so you access the data out of a list and a tuple with an index number. And then to get data out of a dictionary, you use a key. Right? So you supply some keys and some values, you get data out using the key. That's kind of cool. So this will bring this. So games genre equals fighter here, right? That would equal fighter. So yeah, so I feel like our Pokemon example in our last season was a little bit more organic, the way we kind of moved along. We started off very simple, and we kind of gradually gained complexity in a way that I was more happy with. This time, we're kind of jumping pretty far ahead in some complex concepts. I apologize about that, but it's kind of a necessity for our genre here, which is a adventure game. I promise, guys, that on next Friday, our game's gonna really come together with some of these concepts. We're gonna have a pretty cool adventure game on our hands. We can actually explore a dungeon and find some cool treasure and that sort of thing. Today we really just mostly talked about some very abstract concepts, like different data types and how to use lists and that sort of thing, how to use boolean values, etc. But before we call it a night here, guys, move on to some Mario Tennis. Why don't we go and look at our game and run it here real quick? Let's review the game one more time as it stands right now. So the way the game stands right now is when we first launch our program, the thing that it does is that it reads these function definitions here and defines these functions for us. So we've got one function for every command in the game, and they're named for our convenience after the command itself. So we got look around as a function, takes an argument here, does some stuff. We've got do a dance, doesn't need any arguments, just prints off some data, prints off some strings. We have open the chest, we got get the key, leave the cave, get the torch, open the door, and unlock the door, right? Those are our four, those are our functions we defined to make the game work. After our function definitions, we actually make some variables that our code needs to work, such as is the chest open or not? Right? Chest is open, that equals false from the get-go. Then is the door unlocked? Well, it's false. The door is locked from the get-go. Is the door open? Well, it's also false. It's closed and it's locked. We have a player inventory, which starts off as an empty list. Right? It has nothing in it at the start of the game. And then is the adventure ongoing? Adventure is ongoing? Well, that's true. At the start of the game, you're on your adventure and you're still adventuring. Then we say, hey, listen, while the adventure is ongoing, so as long as that value is true, keep on asking the player for commands. Right, so give them a little input there, what you want to do. Whatever they type, then save it to the player command. Right, so whatever they type in, save it to the player command. And then we ask, well, whatever they typed in, is it this? Is it look around? Is it do a dance? So they type in open the chest, so they type in get the key. Was it leave the cave? Was it get the torch? And then we run the appropriate function. Right, so if it was look around, then run look around with the argument that it needs, the player inventory. If it was do a dance, then do the dance with the argument that it needs, which is nothing. Doesn't need any arguments. We have open the chest, we have get the key, etc., etc. One for every command in the game. Then we say at the very end, else. So if we tried all the above commands, and it wasn't any of the commands that you typed in, then just say you can't do that. Right? That command you typed in doesn't exist. It's not a real thing. Type it again. Then we print off a blank line, and then we go back to the top. That's how a while loop works, right? The while loops, they go from top to bottom, then they go right back to the top again. And ask the question again. Is the adventure still ongoing? If so, run it again. Then it goes back to the top. Is the adventure still ongoing? And the adventure becomes, not ongoing anymore right here. If they successfully leave the cave, the adventure is ongoing, becomes false. This loop will stop. We get down here to the game over and ends the program. Do the methods need to be defined above the calls at the end? Or can Python look around to find different methods when called if they're defined afterwards, Vencabot? They have to be defined at first, Skullcrusher. I'll demonstrate that right now. If we go back to our other example program here, and delete this nonsense. And let's just, say, do a thing. And, hi. Right, let me say, define, do a thing, greeting is the argument. Let me print off, the greeting. That's all we do. Even classes, Kenny. Oh no, I think I know what Kenny means there. That's actually, it's not an exception really. I wish I had time to explain how that works. But let's run this here. So we have this simple data types, right? Okay, so it's a name error. Do a thing is not defined, right? Because we haven't defined do a thing by the time we call it. Yeah, in Python it's still a thing. You have to actually define things first before you call them. And for Kenny here, I'm going to do another example real quick. Let's actually make this run correctly. If you guys are totally new to Python, please close your eyes and plug your ears, lest you be molested by this relatively advanced concept. For Kenny, let's say, we'll make a class here. Class, this is something. When we initialize it, just takes no arguments. And it runs self dot, do that shit. Right? Just do that shit. Obviously, why would you do that shit? Right. Then you define right down here. Define, do that shit. It takes self, like any method. And it prints off, we doing it. Because we're doing it well. Now we can make a new object. Let's just say, my thing is something. And that will run this statement here. I'll print that message off. Let's demonstrate. There, it says we're doing it, right? So it actually worked. So what Kenny was saying is that, in this case, it appears that we actually were able to call the function before we defined it, right? So that kind of goes against what I just showed you guys, right? But here's the thing, though. This function is not called until we initialize an object, right? So when Python reads this code, it defines the class, then defines all the functions, but it doesn't run them. It just defines them. And then down here, we run the function. So by this point, we've already defined this, right? So we're not calling it before it was defined. We're just, we've written it before it was defined, but we're not calling it first. We can do the same thing with functions even, right? We can do let's do the same thing with functions. I'll leave that there for now. But let's say, we define a function. Let's just say we'll call this function A. Right, let's define it first. So define function A, and all it does is it calls function B. Right. Let me define function B. It prints off, we're running function B. Okay. So now we can call function A. There you go. Let's do it. Oh, yeah, call function A. Yeah. Okay, it says we're running function B. Right, so in this case, we have the name function B put in the code, like visually, above function B. So you might think that we're calling it before it's defined, right? But this is the thing, we're not calling it. We're not actually calling it here. It's not being called before it's defined because this code doesn't run until we call function A. So we're calling function A down here. At that point, we're calling function B. And by then, because we started off down here, function B has already been defined. You know what I mean, Kenny? So yeah, so you can't, in Python, you can never use a named piece of data, be it a function or a variable or whatever, before it's defined. But if your code is indented, that means that code will only run under certain circumstances, right? In the case of a function, that code will only run if that function is called. So yeah, function B appears here before it's defined, but it's not used before it's defined. By the time it's used down here, it's already been defined. You know what I mean? So that's true whether you're in a class or whether you're making functions or any case. You can't really use a piece of data before you defined it, but you can write it before that. It's just that you can't call it. You can't actually make that code run yet. Thank you guys for hanging out. Again, I apologize. I feel like compared to our Pokemon example in our first season, this has gotten pretty complex. Thanks for the follow. This is Coder. Wow, this is Coder. It's a very literal handle, huh? This is Coder. Welcome aboard, dude. I'm David. We program here on Fridays for the first part of our stream. We're more of a gameplay stream. We stream gameplay here Monday through Thursday, and then most of Friday as well. But on Friday, around 6 to 8 p.m., excuse me, 6 to 9 p.m.-ish, we do programming. And that's ending right about now, guys. We're going to be moving on to some Mario Tennis now. Thank you again, guys, for hanging out with me here. I feel like our adventure game example has kind of gotten ahead of itself. It's kind of hard to make an adventure game without going into some advanced concepts. Whereas Pokemon was more like a linear progression from being simple to more advanced. So if you guys want a more competent beginner example of programming a very simple game that gradually evolves, go check me out on YouTube at youtube.com/VencabotArchive and go watch our Pokemon example. In this case, though, on next Friday, our adventure game is going to get pretty fucking cool. It's going to actually get some more rooms involved. We're going to actually do some more exploring. We're going to find some more treasure, maybe even fight some monsters. Who knows? Light Skin Kanye says, I want to get better at coding. Can we use a real language to learn instead of Python? No, not on this channel, Light Skin. If you want to, I'm sure there's plenty of resources to learn, like Java, very popular in industry, C++, was very popular in industry. Python is becoming more and more popular in the professional space, but it is definitely much more attractive to some hobbyist programmers in particular, because it's very simple to understand and to read and to write and to extend. But yeah. English, that's true. English is a real language. YouTube's written in Python. It's pretty decent. Yeah, Python is pretty godlike. I love Python. But indeed, if you want to learn some more traditional professional languages, there's plenty of resources for that as well, like Java and C++, JavaScript, etc. If you enjoy the channel, I'm going to keep it online. Check my Patreon page, patreon.com/Vencabot. Even a buck is a huge help. Also, you can help out the channel for free by following, tell your friends we're here, and save clips. Also, we're on YouTube, like I said, youtube.com/VencabotArchive. We have all kinds of cool gameplay there, but also programming streams. We've got, again, some more simple examples. We got our last entire season of Intro to Python, which is our Pokemon example. We start off very simple and end with a fully working version of a Pokemon battle, including the ability to make your own Pokemon and your own attacks and that kind of thing. Do you do C++ as well? I used to, Sniper. I used to use C++ and Java and JavaScript, but now I pretty much only use Python. It's my favorite language. Thank you, Solo Techno, for the follow. I'm going to go a very short break, guys. Come right back with some Mario Tennis on the Nintendo Switch. I'll see you guys very shortly. Welcome aboard, guys. We got a little bit late here. We're just ending our programming stream. We program here on Fridays right now. That's Fridays at around 6 p.m.-ish to around 9 p.m.-ish Eastern Time. Yo, turkey sandwich. Yeah, next week, guys, on Friday, right now, we're going to be returning to our adventure game example here and learning about object-oriented programming. We're going to talk about classes and inheritance and how we can use all these concepts we've learned to come together and make a really cool, adventure game. Thank you for the reminder, Sniper. Let's run our game, shall we? We'll run our game one more time here for Sniper. Before we call it a night here. Let's see what we've got, what we finished today, huh? Let's actually expand this a little bit here. For Sniper. So here's our game, Sniper. Let's go look at it real quick. So here's what we've written today. It's about, maybe close to 200 lines of Python, maybe a little more than 100 lines of Python. And the result is a very simple game example where we are in a cave and we're asked, what do we want to do? Well, again, we can do a few different things. We can do a dance. Okay, we can perform a break dance. We can try and open a door. Well, let's look around. We can look around. The cave is dank. There's a treasure chest. Okay, there's also a door and a torch. Well, we can get the torch. That's cool. If we look around now, and we got the torch. You see the torch is empty. Now there's no torch in that spot anymore. We can, try and open the door. The door is locked. We can try and open the chest. Okay, there's a key inside the chest. Well, can we try and unlock the door without the key? Okay, I don't have a key to open the door yet. We can get the key, though, from the chest. Okay, then we can, unlock the door. We can leave the cave. So now it's dank and lit? Wow, Steve. Wow. Steve, ban yourself, dude. Ban yourself. We missed the final run-through of what the game does for the day. Thank you, Skull Crusher, indeed. He said, I still have a hard time with Python's requirement for tab indentation instead of curly brackets. If you're used to using C++ or Java or JavaScript, it's kind of a little bit of an adjustment. But to me, that's Python's strength. Its main strength is the syntax. The syntax is so clutch in Python. It makes it so much easier to read, less characters, more uniformity, that sort of thing. Anyway, guys, it's time for Mario Tennis, that is. I'll see you guys very shortly. I would ban you, Steve, but the last time I did that, I did it on accident to somebody, and it was like for like 10,000 years. I was like trying to like time them out. I assume that timeout like defaulted to like 10 minutes. So I was like timeout, you know, Overlord Steve or Zanzu or whatever. And it was like, they've been timed out for 10,000 years. I was like, well, shit. I'm scared to fuck with that. Hey there, big guy. I'm not trying to ban somebody for 10,000 years. I think here goes, you're right, I do. Oh, it still says Middle Slug? I'm sorry, holy shit. I forgot I hadn't fixed that. What's your question, Sniper? A game like Fortnite, in which language was made? Like Fortnite, most likely C++. Or a more modern language, perhaps, like C# or something. Probably not C#, probably C++. Even on health right now. Oh, man, taking a Caraxa. But again, that was made by teams of hundreds, Sniper. That was made by teams of hundreds. He's gonna survive this. Not just one person. I take it back. It was made over the course of many months. Wow! Herb Durkin, that was sick! We're focused more on, you know, the first day programming for somebody who's never programmed before in their lives. We're trying to make very small projects here, very small example projects to teach the basics of, you know, how to write programs. And indeed, it does use an engine as well, almost certainly. Yeah, modern AAA video games are very, very involved. They're very impressive. They require a lot of coordination, a lot of expertise. Not just programmers, but also artists and musicians. People that can create beautiful graphics and beautiful sound. And it's the programmer's job to make it all work. The programmer's job is to make sure that the actual game is playable. Right? The game becomes playable thanks to the programmers. But a programmer does not make a game, such as Fortnite. Right? It's made up of many different components. So, you know, the programming, the artwork, the music, the player base, the community. Oh, wow! That charge was so... There are some examples of games that were made by teams of one, or very small teams. Such as, you know, of course, Undertale was made by mostly one man, who was the graphics designer, the lead musician, and the programmer. There was also some help with the graphics in that game. There was also Cave Story. Cave Story was made by pretty much one guy. Stardew Valley, I think might have been... Was it one man or was it brothers? Might be one guy. In any case, there are some examples of indie games that were truly made by one person. Minecraft was originally developed by one man, but nowadays is made by a very large team. You know, Minecraft Classic, as it's called, I believe, was made by one guy, pretty much. Is a bitch. Backspace. But I can't help but feel like, you know, if your goal is to watch a Twitch stream and leave that Twitch stream making a game like Fortnite, then I feel like you don't really understand what goes into a project like that. You know what I mean? Here goes. I'm not going to buy MK11, no. I have no money at all. Nor will I ever in the near future. 10 years, wow, Stardew Valley.